Hello. It is time. Alright. I failed. I failed. More than once. But now I'm here. So here has been my lesson. Have a backup plan. And don't expect success instantly. I feel like those aren't lessons, honestly. Those are just things that I forgot to do. Anyway, my backup plan. Alright, so I'm doing this. Fixed leg rotations over time. This is not an impossible task. It will take some reading. I already have an idea of how I might be able to accomplish it, and it, don't expect to work, but it's my idea. And if it doesn't work, then I try something else. So here's the idea. It will, at this point, it's pretty clear, it will require manual tweaking of the engine to be able to do this. But I think what I should be able to do is expose the work that Chain IK is doing, which, let probably a good idea to open one of these. I don't know if it's going to. Here's what I would love to do. I would love to be able to search for this anyway. Can I just... I know that you say you don't have this, but can I just search it anyway, please? Okay, so it's not going to let me. But I know it's here because it has to be here. Should be in nodes. Yeah, see, I don't change. Okay, so chain IK3D appears here when I type in chain, but if I go for IK. Yeah, okay, so that's kind of a... Alright. I know it's really bad. I know it's bad. I need to move on. I need to have work. I need to do things. So chain IK goes to iterate IK3D and spline IK3D. Somewhere in here, the work of stuff is like actually saved. I have chain, which is a vector. This is actually a packed vector. Okay, I don't think local vector, but vector 3 is essentially the packed vector 3. I believe local vector, I think it's just like, honestly, I think it's just straight up a type def for vector. Or not a type def, it's like an implementation of vector or array or something that has less functions on it or something. It does less stuff. It's meant for like internal only use. So what I'm assuming all of them do. All of the okay, 1 second. Thought it was working. I'm back. You know what's like I feel like is wild? My dog knows. My dog just knows. The last 2 days, he didn't need to go out constantly and he wasn't barking constantly. And on both sides of that, the day prior and today, he's already barking, and I'm assuming it's only a matter of time before he bugs me to go out again. I took him out literally right before I started. It's just gonna happen. It's gonna happen. It's gonna be annoying. Oh well. What I'm saying here, chain IK3D, this method is called by whatever CCD IK, I think it is. This one's called. It gives it an update chain coordinate FW. Maybe is it like forwards or backwards? Is that what this means? Because these two look really similar. Head to tail, current vector. Result minus chain head, chain tail minus result. I'm guessing it's the same thing, but it's like flipped. Yeah, in this case we're updating head, and in this case we're updating tail. So tail is the index we give, head is the index we give. Yeah, it's like a forwards and backwards type thing. I'm not really sure exactly what it means, but we're updating chain. We're updating chain. I wish I had these in folders. CCDIK. What this one does is solve iteration. Oh, I guess runs through everything. Backwards, forwards. Okay. It calls. What does it do? Head, tail. Chain size -1. I'm guessing effector is the target point. No. Effector is the end of the chain that you're trying to reach destination. That's what you're trying to do. I don't know if I said my exact idea, but my exact idea is to somehow, whatever the virtual bone structure that all the IK uses, expose that as a resource, and then what I can do is at the beginning of each process tick or physics tick or wherever I set it to be, I open up that box of data and I say, all right, that's cool. Let's rotate these into their rest positions. And that's it. I guess I don't open the box. What I'll say is iterate IK3D will just have a setting that I can turn on that will say prior to every run, we go to that chain list, or I'm thinking it's going to be the chain list, and we move the chain towards the rest position. So here it creates, okay, so it just grabs all the data. This is just grabbing data. Solver info. If not solver info. What do we do with solver info? Solver info forward vector. Get limited rotation, get projected rotation. This doesn't even do the math. Interesting. Or perhaps joint settings is something custom for... Yeah, now that I'm looking at it, we just basically get a rotation, we grab all the vectors, and we just call this method. Update chain coordinate forward. And then if we have an axis limitation, a rotation axis limitation, which I'm assuming is what that means, then we call it again with a projected rotation. And then if we have a limitation, then we call it again. Tail. I guess this is the math part of it. Current head plus rotation transform tail. Yeah, see, this one's actually really heavy. One iteration reads through the entire chain. I is ancestor. Ancestor is joint size -1. So we start at the end of the list and we go to the front. And then we start from that point and we go So we start at the last point and we go forward. So it's like reading the whole list. Is that not like... I mean, that's, yeah. Doing this twice is already pretty heavy. Doing this 32 times a frame, way too heavy. Okay. Alright, and I can't scroll all the way. So this says get projected rotation, then it says get limited rotation. I wish I could just click these without doing that. Current global rest. And I'm assuming this is this is an index to tell at what part of the chain to update. And then maybe this is a forward vector. Okay, so there is joint settings. So iterate IK3D setting has this joint settings here, and it specifically needs an iterate IK3D setting. So my thinking is this method is on iterate IK3D setting. So I'll look here. Iterate IK3D joint setting. Let me double check that. So we give an iterate IK3D setting. I say joint settings. Okay, so this is a joint setting. So it's from there. So iterate normal setting contains joint settings, simulated node path target. There's the cache and init joints. And then here's get projected rotation, which I don't really need to worry about the math behind this. Get a limited rotation. Okay. Joint settings. All right, my thinking behind this has been an iterate IK3D setting, or just iterate IK3D, where it runs, this is the big entry point, process IK. I do call init joints for each setting. And a setting is the chain, effectively. So maybe what I can do is inside of init joints, I ask, this could even be on or a per chain setting as well. Maybe that would be better. And essentially, what it will do is somehow transform them back. Clear joints. Mem delete. Simulation dirty. And I think simulation... is this... I want to see if this is specifically on, because it looked like this was doing setting. Is this specifically on the setting? They're simulated. Okay, so is this a chain IK setting? What else is there? Is there a IK modifier? IK modifier 3D setting. As the simulation thing. It calls make simulation. So this is per setting. Is a chain IK a simulation IK? or an IK3D, yeah, IK modifier setting. Okay. Okay. So go here. Oh, it's not even ever called there. Okay, so the only time this can be set to true is in here. Or at least if make simulation is called. So anytime I update a setting, anytime you see index, this is a setting index, this is a setting for a whole chain. So we mark that whole chain as essentially needing to be reset. Because when we get into simulation, it will clear the joints, it will init the joints, and then it sets it to false. Right. So kind of what I would like here is probably to have a, probably after deterministic, have like a setting, it can't be deterministic, and it can't need to be remade. So at this point, it would be like if setting correction angle or something. Or yeah, I think the best way to go is a correction angle. Compute the angle between the current chain and its rest, and then ensure that I go back to it no more than some number of degrees. So that way I can say, all right, on each iteration we want to move up to 2 degrees, but then prior to, not every iteration, but prior to, I guess it could actually be prior to every iteration. Maybe not prior to every iteration, probably just prior to running it all. It will basically just create 2 quaternions, compare the angle, use that, which is kind of what I had written, or not kind of, exactly what I'd written. I would get the full axis angle, and then I would quaternion angle, and I would divide that by the maximum and then clamp that to 0 to 1. So this would be like if setting correction angle, I would do setting fixed joints or setting correct joints, right? None of the setting stuff is defined here, I think. Yeah, none of the setting stuff is here, so everything that settings does is all written up here. So what I'm thinking I do is, I mean, the knowledge for however this is set up is definitely in here. In cache current joint rotations and init joints. Everything I need should be here. Yeah, and probably it's best that I put it on each setting individually. That's probably best. So it'd be like in here. Okay, so not a joint setting specifically. Yeah, I think it would have to be here. It'd be a new line here. Cache current joint rotations, I guess I'd need to read it again. But I think what this does is that it grabs the parent. Because the coordinate that we're targeting is like a global coordinate, if the parent moves, or essentially I guess the parent of bone moves, it needs to transform that entire chain by whatever the parent did, and then it can just continue iterating on the chain from there. But then I think init joints, what it does is it will read through the current bone pose, right? Get bone global pose. And add each... Yeah, it'll add each one. I got caught up because I saw get bone rest, which is actually like a direction, or I guess the axis. It's trying to compute an axis here. That's a bit weird. And then I'm guessing solver info list is meant to be like a cache, like is the cache. Probably. There's also cache current vectors, which is part of chain IK3D setting. But look at init joints. Also, there might be a possibility that there's some like simple call on chain IK that kind of tells me this is how it should be, essentially. Cache current vector from an index, essentially using the tail. So if you give it an index, I give it this point and its parent point. So it's this bone, it's the vector pointing at this bone, right? Is that what this means? If current head is greater than or equal to 0, so this is actually a real bone. Well, I guess it saves both of them, and it saves the tail and the head. Yeah, this is just the same line twice. I'll be right back. I gotta... Yeah, one sec. I'm back. Okay. Solve recurrent, yeah, what I was gonna look at next was... No, it'd be, wait, is it here? It would be IK modifier, probably here. Because it does process modification, an IK modifier 3D process modification. Right, skeleton modifier. What's the order? IK modifier 3D must have it. It's probably actually in... It might actually be in chain. I don't know where I'm going. See, this is one of the things that I hate about doing this, because I literally have to look at... Maybe it's chain IK, I don't know. I have to check at least 2 files, because they love to just mix stuff in the header file and the compiled file. Like here. I mean, I could make the statement say, okay, you know, all of the code for this class is right here. Sure, whatever. But then 2 functions from chain IK3D are defined in the header file. What if I was looking for set setting count? Well, the first thing I would have to do, also this is a virtual, so I would have to go to, essentially either start at the top and go down, or the bottom and go up, and look at every header file, and then the compiled file. Because usually they're not here either. You can say one thing, all right, well, every virtual one is put in the compiled, or every virtual is put in the header, but even that doesn't work, because they're just, sometimes they're there. Sometimes they get really terrible, and they'll do it on one line, and that one line just shoots off to the side. So you open the header file, and you don't see code immediately on your screen, so you're like, okay, well, it must be in the compiled. Then you can't find it there, and then you go back to the header file, and then, oh, it was all on the one line. Ah, dude. Why do they do it? I feel like working on a project for more than 3 times ever, you would immediately say, all right, this is awful. Let's only do compiled files. And if we want something to be in a header file, we make an include file. So then it's really obvious where that piece of code is. But not even then, because then you're like, okay, well, I don't know if the method was inlined or not, so I have to look at the header file to see if it says inline, then it does, and then I look at the include file, but then that doesn't work because sometimes they say inline and then it's defined at the bottom of the header file instead of an include file. Sometimes they do both. Sometimes they have inline in the header file, some of them are defined in that header file, and then there's a include file that then inlines some other functions. God, it's so stupid. Why do they do this? Oh man, now I'm getting distracted. I'm doing it again. Okay. I'm just trying to see where it starts from. I think there's a process modification, and then one of these has their own process modification. I think it's something like that. I just have to find out where it is. There's process IK. Okay, then it must be an iterate. I'm just gonna guess this file. Process IK, process joints. So init joins, process joints does solve. And then right here, this is what I'm looking at. Apply the poses to the actual bones. Solver info, current L pose. Local pose. Solver info. The weird thing is that it is in two places. Ah. Okay. Cache current joint rotations looks like what it does is it runs through the chain update and then it saves these solver info current poses is my guess. So I'm going to look at cache current joint rotations, which is going to be here. Cache current joint rotations. Oh, really? My guess is that that's what this does, so I'm going to look for current L pose, rotation access all, L rest, diff previous current. We do some update, angle 2, not 0, interpolate. Okay. So how does it do this? Solver info current L pose. Is that updated here? Or down? Or... is that all the L pose? Okay, I'll read cache current joint rotations because that's called after a solve iteration, which means this can't mess with the chain. Apply back angular delta limit to the chain coordinates. Chain 0 is get root bone solver info current pose, solver info forward vector, current pose. Okay. So the chain is the chain a cache then? So solver uses, it must use L pose somehow. When we do actual iteration, we must be using lpos. Local pose. So back to chain IK3DH, update chain forward is what they always call. So this does the index into position, result, chain, cache current vector, okay. Init current joint rotations. There's no reading from it. Oh, there is reading from itself. L rest. Oh no, we get global rest as L rest. Normalize. I guess these are always rotations. Oh yeah, they're quaternions. L pose is bone pose. I remember reading this and thinking this was just silly, because they read in the same bone pose. And these actually end up all having current L rest, G rest, and L pose and G pose actually end up with the same values. So that was funny, but definitely inefficient. Cache current vectors is just directions. Update chain forward. Okay. Update chain coordinate. Tail. To rotation. To rotation is a quaternion, head to effector normalized, head to destination normalized. To tail. Chain tail minus current head. And then we do those. Projected rotation, limited rotation, update coordinates. I believe that's an iterate. Here. Or it's not. It's not. I'm trying to see where it connects from chain to solver L pose. I'm trying to see where that happens. I'm not seeing where that happens. Process IK init joints cache current joint rotations outside of the chain bone pose changes. Destination process joints. Yeah, at this point it already has to be here. Cache current joint rotations must be doing it. Cache current joint rotations. They even have to call it first before we run through the solver. Okay, cache current joint rotations has got to be it. But it looks weird because it seems like this is not. It's doing more than what it looks like it's doing. So we get to each joint. L rest. We just obtain its rest position, its global rest. Previous L pose, we update the L pose. Forward vector. Okay, so it looks like L pose. Okay, so this is it. This is it. And then we just go through and we update the chain. So it's a weird thing. It looks like it reads in data from the chain, and then it writes to... Let me look. Then we go to chain IK, and it writes to... Well, it writes the position back, and then it obtains a current vector, which is effectively its rotation, in a way. Not IK modifier. Iterate IK. And then it essentially goes through all the joints, reads in, it updates the rest values, I guess, then does from, and then to, and then it obtains this, and it says, all right, our new pose is this one. Our new pose is this one, and it does, okay, well, if we go too far, I guess if we have a difference, then we need to limit that difference. Using smooth spherical interpolations. Okay. All right. So okay, so if I understand this right, I believe L pose is generated exactly this. I mean, L pose is. I know because I saw it uses rest, which is actually just a current bone pose. So it takes this in. So I can think of this as L pose, literally. It does the same thing. And it is the rotation quaternion of the bone pose, as it is. All right. So what I think I can do, let me see. L rest. Let me just double check what these are doing. L pose does take an L rest. Get swing, which I'm assuming is from... I'm looking in the wrong place. Get swing probably comes from chain IK. Or maybe even IK modifier or whatever setting. One of those two places is where this comes from. Okay, so if I'm going to take the L pose and update it, angular delta limit, I'm assuming angular delta limit is never provided. It is just always going to be pi. That's my guess. So let me see if that's the case. Okay, this one does take in an angular limit, angular delta limit, which is on the iterate IK3D. Okay, so it looks like essentially the solver does, it just creates the chain, it makes the new chain, and then it limits all the rotations after the fact to whatever you set it to, and then it just keeps doing that over and over again. That's not what I would have thought it would do. I would have thought that it would, I mean, I guess it has to do that. So I guess, I mean, yeah, okay, that's fine. Okay. So all right, now here, I guess here's the question. Do I put this on, I probably honestly put it on settings, but the angular delta limit is put onto, I guess here's my thinking. What if you want to have multiple chains on your IK, but you only want one of them to be fixing, or maybe you want one of them to have a high fix rate and another one to have a lower fix rate? Either you have to make you have to create two different IK nodes, IK modifiers, and run those with their own settings. Or you could have the one, and then per joint you would have to set up everything. I guess that's the question. But where we use it, we do have direct access to the setting, so the setting could store it. And cache current joint rotations is an iterate IK 3D setting specific thing. So I could literally have it in here, where I have L rest, and I could interpolate back to this. So what I could say is this is some kind of previous and new. I interpolate towards the new one, and then I guess after that, no, I need to do it before that. Okay. Okay, but cache does technically always run prior to it. I think I just want it to run once. I don't want it to run every iteration. I just want it to run the one time. So the order is IK, iterate IK, joint, rotate back to positions. Sorry, not joint. We get the chain, rotate back to rest, and then we do iterations. And my thinking there is that doing it in that order prevents it from flickering, I guess, where it'll snap to it and I'll bring it back, and then it will snap to it and I'll bring it away. Instead, I want it to bring it away, then it can snap, renders, bring it away, then it can snap, renders, right? Yeah, because definitely in the other case, if I'm bringing it back, then until like the very end, it's always going to, in fact, not even that, it's never going to sit on it, and it's always going to be some angle away from it. So it has to run before all the iterations, at least before an iteration. And since they're all in here, I kind of can put it per setting. Right, this is per joint. Props, pushback, something. So yeah, essentially here, I kind of want to do it on this one. I guess what I could do is I could read in and I can ask if the current angle limit is pi, then I know this is a... not really. I want to do it the one time. And preferably adding code that works on its own. Preferably, I would just insert some code in one place. I could make it a function. That'd probably be best. Because right here, what I could do is I could just say on this setting, I would say iterate ik settings, I correct joint rotations. And that would be the one call. Because process ik happens once, and then that is where iteration happens inside. And instead of iterate ik, I would have my new function that would look very similar to this one. It would look very similar to this one. It would essentially run through, not really do this stuff, because this is looking at current rest and get swing from and to. This is, I believe the forward vector updates and the global rest updates. So this is what, or yeah, it uses forward vector and current vector. Or I guess current vector is the one that's updated. Okay. But this is always called. So it's kind of a weird thing where the first time this calls, it's actually just going to, the real intention is just going into here and grabbing this information. I mean, I could add like a Boolean. Hey, Danilin. The Boolean could be true. Or it could just be like the actual angle. It could be like skeleton double rest angle, and I'll just pass 0 for the iterations. And then for the initial call, it would contain the settings thing. And then it would be it would essentially be this call here. Maybe it wouldn't be that call. I do get the rest. I technically have it here. And I think what I can do is I can just have I can effectively do this. I can do L pose, angle to L rest, or I would check the correction, and then if it has a correction, I interpolate L pose into that. Right, I think that's it. I think I add the setting. Not to... Ooh, wait a second. Not to joint. Well, this comes in from each joint. Oh, no. No, if it's on each joint, I still have it on each joint. Okay. I think it's what I'm looking for. I might have it. Okay, we're clean. I'm not looking at chain IK, but I do kind of need to look at all of these. Let me just make sure that these are... Okay. Alright, so first thing, I need this on a joint setting. So I will have a float. I'll have a rest correction angle, which will just be 0 for no corrections. I guess I need... I guess I don't... No, I don't need a set there. I need a set somewhere around here. Set joint limitation rotation axis. Something like that. Set joint rest correction angle. Const. Okay. But then I also will just have to do a check for like if we're in deterministic mode, because then we just should skip that every time. Okay. All right, now somewhere up here. So my thinking is I add in a double P rest correction. Yep. And then here's what I want to do, I think. Pretty much right here. Yeah, right on previous. If I'm given a rest correction, how do I apply it? I mean, I think I just apply it right here. And then I allow that angular limit to take over. Oh, no. I correct it before I have a previous. I just correct it right away. So I'll say if... well, not that. I think it really means to say this. If p rest correction is greater than 0, then I'm doing a correction here. So what I do is I say double angle can be solver info current L pose angle 2 solver info. What do they say? Current L pose. Yeah, current L pose. And then solver info L pose equals info current L pose S lerp angle 2 L rest is what I meant to write here. L rest. And then yeah, I guess it's just really similar. So if I have a positive rest correction, I compute the angle. I do solver L pose equals current L pose, interpolate to L rest. And yeah, my thinking is that if I'm giving a rest correction, then that's exactly all that I do. If I don't have a rest correction, then I use the angular delta limit. So I could wrap that in else, but I think I'll just leave it open. And this could actually move up. So after we do the correction, then we do an angle limit for new rotations, but these two shouldn't be happening at the same time. Oh, and they do it a weird way too. I actually want this to be angle over that. No, that is correct. Is that right? Yeah, because I want to do the whole angle as much as possible. But if the angle's like 90 degrees and I only want to correct 2, then I want to correct 2 out of 90 degrees. Right, okay, so just like that. So that writes like that, and then back here, when I run process IK, I need to pass in iterate settings I called it joiners. Wait. Joints. Oh, hang on. Oh no, this is right. Yeah, I don't know why I wrote that there. It is supposed to go here. And it's not by joint, it's by the whole thing. Set rest correction, get rest correction. So each chain I could turn it on or turn it off per chain. So I guess I actually don't even need it here. But I feel like I kind of do. I need it there because I need to know when to not do it. So knowing when to not do it is... Oh my gosh, what is it called? Rest correction angle. I give a rest correction angle, and on each one of these, I'm just giving it zeros. So for each chain, before I do anything, I take the current solution, I spin it back a little bit, and then I allow iteration to move it away from that point. Okay. Pass another correction angle, then here I pass 0. Should be all I do there. And up here, I just accept that, and if I have a value, I rotate it back. The set rest correction, get rest correction. Right, okay, so that is what I'm missing. I do need to have those. Which I believe are up top. Should just be right beneath set target node, yeah. angle, index and angle. Okay. I guess these can be real types, actually. I'll just make it double. Because that's how it's given, that's how I'm going to use it. How's it going, John? It's going alright so far. But we'll find out how long that lasts. Okay, so back here I need to make these doubles. Double. So those, and then there actually is nothing per joint here. So I guess I do have this. Yeah, okay. Yeah, I guess that's what we're doing. Rest correction, which that's just the same name that I give up here. So everywhere that target node appears, or just about everywhere that target node appears, I need a couple a similar thing with the rest correction. I'm going to set up a floating orb. I want to follow the route. Good luck with that. There are a lot of annoying things with Godot for sure. Perhaps I should have this limited to be, well, I guess if it's negative, it just doesn't even do anything, so it's fine. It does have to be positive. Though I could run, like, I guess I can use min and max as a clamp. Is it math pi like that? It's written up here. Math lowercase pi. So smaller value between angle and pi, and then the larger value between that and 0. So it will be fixed between 0 and pi. What if clamp is anywhere here? I'm doing it like that, whatever. Oh, and then I have to do the deterministic check. It does matter very much if it's deterministic or not. So inside of, am I sure that these are all correct? Yeah, I mean, I see rest correction angle everywhere. Okay. And then it is by chain. Yeah, deterministic has to be off. So I guess right here I can actually write is deterministic or deterministic. Because somewhere up here it does that. If deterministic. So if it's deterministic, we pass in 0, otherwise we pass in the rest correction angle. Okay, what do we look like right now? Get rest, set rest. Whoa, sorry. All the same name. Set rest, get rest. Between 0 and pi. Set rest, get rest. If we are deterministic, we give 0. Otherwise, if we're not, then we give that angle correction. That happens once per setting, which is fine. It's not really a big slowdown. And then there we always pass 0. It initializes at 0. Which, now that I think about it, I'm not exactly done. Up here, I think it's up here. Yeah, we're giving this. Yeah, I need to do this extra stuff here. Like this. I do property hint range, something like that, which is it's here. Property hint range. Exactly this, in fact. Grab that. Zero and 180. That seems way too precise, but whatever. I'll leave it the same. Okay, there we go. That should give me what I'm looking for. Okay. Compiling. And this should be slow. A little slow. Maybe not too slow, actually, because it seems like it's remembered. I think turning on or turning off production for testing is definitely better. But probably only worth it if I am not sure of what I'm doing. Or I know I'm going to be compiling a lot. Yeah, I feel like if it doesn't work, then that means I guess I can look to see if I maybe did it wrong, but I think this is the case where if it doesn't work, then my approach was wrong. If it does work, then that's great, it'll work. And it should visually work. Because yeah, looking at how this runs, cache current joint rotations, the only result of this is that L pose, this is actually a great key here to what's really happening. The L pose is the source of truth. This is the one that we update, this is the one that we limit, everything else is built off of local pose. So if I just move local pose back to the rest position, that's exactly what is then read later on for global pose, which is, I don't even know if global pose is used. I feel like this is all kind of probably used for other things, but it doesn't look like these are been used. But yeah, and then chain, I guess it actually does use the global pose to move it. Oh well. Gonna ride my bike? Bye-bye. Alright. Have fun with that. Yeah, I probably should turn off production build. If I fail with this, then I need to turn it off before I try again. Because then I don't know what I'm gonna do. I'm definitely gonna be testing things. All right. Because this would have been a 20-second thing, and now it's going to be like a 2-minute thing. Maybe like a 5-minute thing. And I guess that's a compile. So today would have been 2. Now it is 0. Why is it running 55% CPU? I feel like it could be more than that. Oh, it's done. 3.5 minutes. Yeah, that's... If this doesn't work, gotta go to dev build for like a 20-second compile. So the first thing I should see is that on each chain setting, there should be a rest correction angle thing. Don't care. So iterate IK. There's get rest correction, there's set rest correction. Nice. Those have appeared. Open anyway. Okay, delete that. So on here, when I open up settings, rest correction angles. Okay. I think this runs once per thing, so I could turn this up to 2 degrees, though this does mean that, yeah, it probably shouldn't be much higher than that. I have a slider to 180. All right, I will have the left ones update. I'll have all the left ones correct by 1 degree every go. And I should be able to see it in editor. So if I turn this on and I move this around, what was this one should mess with it? So I would normally see it lay pretty flat when I drag this out. Oh wait, this is the right target. Okay. This is the right target. So this one is not correcting, as you could see. It's obviously not correcting. The left target should be correcting. So I guess I'll see what happens if I move it a little bit. Okay, that's important. I saw a correction happen. Okay, wait, this one is flat now and it's not correcting. This one should be bending down. But I did see it do it a little bit. So my thinking here is this is middle left. Make that 2 degrees. Huh. It may just not be updating. Dang. I guess here's the weird thing. How is this even iterating? Because if I give it 4 degrees, it should be undoing it. It should be completely undoing it. 5 degrees should... I shouldn't even see it here, was my thinking. Because it will be correcting back to 0. Let me turn it off. Okay, so I'll leave the right side of as what it should be looking like. Interesting. How is that working? Whoa. I mean, it's weird. It's definitely doing something, but I don't know why it's not going back. It would have all been up here. Cache current joint rotations. I don't happen to have deterministic turned on, do I? Deterministic is on. It wouldn't run. And I am interpolating back to LRest. Maybe what I'm meant to do is I am meant to be using this one. I rotate it by... I take in L pose. I do this because this is the from and to, which is like it's forward vector, current vector. Yeah, this is like the, this is actually, yeah, this is the result. But then instead of doing this, I would say, okay, well, either way, I need to turn this, I need to go and turn this to, not the one that I wanted. The one that I meant to open, but not the one that I actually wanted open. So this just goes like that. Okay. Yeah, so I think it was wrong to do it this way. I think what I mean to do is essentially write this. If I have a rest correction, then I use my L pose to L rest. Current L rest, and then I interpolate back to that. Okay. And then that's gonna be a while. Okay. I guess while that runs, I probably should look around and see if I have... I mean, I feel like this has got to be right. But if it doesn't work, what could I do next? I think I did make a mistake. I think that was why I didn't see anything happening, was because I was using this, or I was using L pose, which is probably late than I meant to do it. I think I meant to use it here after we apply whatever it thinks the chain should be solved to. Using that, because I think that's where the work is actually put in. The work is put in using this forward and current vector. Because interpolating this is just, it's on its rest, and then L pose is not applying this yet. So L pose should contain nothing, or possibly contains nothing. I don't know. I guess that's the question. Why would L pose not contain the? Why would L pose not already have the solved movement? Okay, let me go to chain IK and see what we're writing to. Update coordinate writes to the chain location, and then it does cache current vector. Ah, okay. All right, so yeah, this contains the solution. Current vector actually contains the solution, which is then applied onto rest. And then possibly init current joint rotations is always called. Is that the case? Does iterate IK3D always call that? Inside of process IK calls init joints. Init joints runs init joints. Init joints clears everything. Init current joint rotations. My thing is possibly it is maybe cleared in some way every frame. Because I did see the motion happening, but I think I might have seen it on both sides, possibly. And I think that's just because of iteration. Because we can only go so many degrees each time. So that's why I saw over time it was getting to a better solution. It was just making very small corrections until it finally got there. And that wasn't the rest stuff. Because if it is, if it is working, I should see if it's in a messed up pose at rest with the target being at rest, then it should fix. It should just fix. It should even be the case that if I set a really high correction angle, it should like fully reset as well. It shouldn't be able to, it should not be able to okay, cache current vectors does update current vectors. All right. I was going to say, my assumption is that if I provide a very high reset angle, the IK can't even do anything. If I provide 4, the IK shouldn't be able to do anything. It should, if I drag it out to the end to be this, and then I say, all right, reset with 4 degrees every time, it should essentially All right, if I say reset with 5 degrees, it should essentially come back 1 degree, come back 1 degree, come back 1 degree, and then reset to looking like no IK was happening. That's what it should happen. If I provide a high enough angle, it should come back to looking like it wasn't even doing IK. Because after each iteration, or if I have 2 iterations of 2 degrees each, I'll bring everything back 5 degrees, and it'll go 2 degrees, 4 degrees, back 5, 2 degrees, 4 degrees, back 5. So it'd be losing like a degree of IK every frame. So yeah, if I'm even having an effect, I need to see it come back. Maybe it'll be wrong, maybe it'll be too strong, some other things, but no matter what, I should be able to make it. I should be able to find a place that brings it back. And because I see that cache current vectors runs, I guess we need to go see what where cache current vectors is. That should just be on chain IK. Cache current vectors. Yeah, it moves the chain. And the current vector is what's used for producing the pose rotation. Okay. Oh, the linking is like instant too. Nice. All right. Launching. And yeah, at this point, yeah, if it fails, I guess I need to find some spot where like maybe I turn off IK or see what turning off IK would look like or whatever. Something like that. So I'll turn these all to 0. So they shouldn't be running. I will enable it to be active. And then I'm going to move this into a messed up position. This should be a messed up position. So yeah, comparing the left and the right here, you can see this one's down a lot further than that one. Okay, so this is the left, middle left, middle left. So where I see middle left target, if I type in 1, I feel like this should be enough to make it fix. Whoa, that came back really, really fast. Okay. I like that. However, now the question is, if I make you go over here, and then I turn it on. That was really powerful too. I didn't expect it to be so powerful. But now I turn it on to 1. Okay. All right. And maybe, oh, that's not what I expected to see. So that's where it wants to sit it at. But yeah, my expectation is that, or it will still stay the same place, but if I turn it like, I'll make it very slightly over. I expect to see this return as if no IK was happening at this point. Ooh, interesting. I'm not seeing it return like that. If I give it a high enough angle, it should act like no IK is happening. Interesting. All right, 10 was enough to almost get it back there. All right, 8 gets us there. This is not what no IK looks like, though. Interesting. I guess it technically... Okay, so I guess technically what is happening is it is running effectively 2... So it resets it, and then it applies 1 IK run around. So 2 iterations of 2 degrees each. So this is what it would look like if it was essentially just deterministic, I guess. This is what it would look like with deterministic. Right, and my reset's not running because I've turned that on. So I could set that to 0, uncheck this, and that's what it looks like. Okay, interesting. So I had to give it a really powerful reset. Alright, but it seems like even a small value is enough to get it there to a better place. So I guess I'd want the smallest value I can get on it. Interesting. Okay. I think I've done it. Maybe 1 degree is probably what I really want, though. Because that kind of has the fastest effect. But I'm surprised that it doesn't have to be... Because yeah, now, so I've set it back to rest. I am going to deliberately mess it up, which is just doing this motion. Pretty much doing this motion. Alright, it corrected like instantly. So if I were to turn this off, double checking that I'm actually in the right spot. If I were to turn this off, it shouldn't even look like nothing should change. Click, yep, nothing changed. Alright. So yeah, I'll put on a 1 degree correction on these. And then walk around with it. It should be going at 1 meter per second. Yeah, legs are still like kind of wrong, but whoop. Yeah, because legs are like stepping a bunch over and over again. Let's go over there. Yeah, it probably does need to be like an individual leg cooldown or something. Like after a leg moves, it shouldn't be allowed to move again. One of its legs is in the ground right now. That's probably just my mistake, maybe. Not sure why the leg is sitting in the ground right there. Because some of them are sitting on top and other ones are like not. Yeah, I don't know, it's a little weird. Well... Oh, I'm good, okay. All of his legs are in good shape. Its body is... Oh yeah, that's still just a problem with how I have legs working right now. They will reset into the ground if they think they should. Or I guess not if they think they should. They forcibly reset themselves into the ground. This is supposed to be a sphere, or like a cylinder shape. But currently it's a sphere shape. The green circle. So it prevents it from standing. It basically prevents a leg from landing anywhere on this raycast and forces it to be within a sphere defined by that circle. It should be defined as a cylinder defined by that circle. Okay. $2 hours. Okay. Yeah, I could have done this last time. I lost. I lost my cool. But that seems like it's working to me. I see them show up. No documentation for it, but I don't care about that. Okay, so I can't imagine right now. I guess if I look ahead, yeah, all this is just doing stuff I've already done before, but that's done. All right, let's turn this back on. Should I probably write all, perhaps? And the UI was correct. It gave me a slider for 1 to 180 in degrees. Though I am a little bit suspicious if I'm actually putting in radians or not. Because the reset didn't quite look correct. I had to put in like 8 or something. Which is a really high value. I expected to put in 5 and it would reset. But I had to put in like 8 before I saw it reset. Yeah, I don't know what that's about. Because it will do 2 iterations, limiting each one to 2 degrees of change, which means the most it can apply to any bone each run is 4 degrees. Perhaps it's just due to how quaternions work, where 4 degrees in quaternions is not necessarily the same as 8 degrees in quaternions. Or 5 degrees in quaternions is not necessarily the same as like 2 steps of 2 degrees. I don't know. So maybe something like that. That is weird though. I feel like that doesn't quite make sense. But it's working. I kind of don't care if there's a mistake, honestly. I don't even know how I could have written a mistake. The only mistake would be this. That would be the only mistake that I could see. But I can't imagine how I got this wrong because I just copied it from another one. If it's deterministic, I don't do resets. If it's not deterministic, I will do resets. There's no crashing. There's no weird stuff. It just runs. I still would like to understand why it only stopped IK from happening after I typed in a value of 8. When I expected it to stop happening after I type in a value any higher than 4. Why would that happen? I think it's just something that I don't understand. It might just literally be something I don't understand about quaternion orientations. I don't like it. That is, I don't feel satisfied. I don't understand that test. Why that test failed. That is a failed test. I was supposed to be able to type in 4 and essentially would lock it. It would never be able to... I mean, sort of. I could see it being a little weird. Maybe it might return. Maybe it would just take a really long time. But I think as soon as I type in a value any higher than 4, IK would turn off, depending on how high I set that value over 4. It would effectively look like it's slowly turning off. -1 iteration, because it still always gets a full iteration without a reset, because the reset happens before iteration. Oh, it might be because I run it... I was going to say it's because I run it prior to the limitation angle, but no, that doesn't make sense either. Because I'm either giving it effectively no limitation by having it be delta, or by having it be math pi. Wait a second. We interpolate previous... Oh, no. It's like a backwards thing. We interpolate previous into its current pose using pi over the diff, which generally should always be 1. Yeah, okay. Dog. He's done it. Okay. I don't understand it. It's working. It's not doing anything strange. But it's gonna bug me for a while. Oh man. Okay. It doesn't matter. It doesn't matter. My best guess is that there's just something that I don't understand about how these angles are really being computed. And I'm not correcting as much as I think I am. Four degrees isn't doing as much correction as I think it's doing. It might even just be a thing where because of the length of the chain, possibly the order that I do this in matters. But if we're doing angle limitations in that same order, then possibly. Okay, I need to leave it. I'm gonna send this, I'm gonna compile it with production on, and then I'm gonna go take my dog out and get lunch. Hang on, Rhett. Good boy. I will take you. Just doing another look over. You know what? I'm actually okay. I think I'm actually happy with that. That might be an explanation. It would take a lot of testing, I think, to figure it out. But I think the explanation is the order that we're running through the joint, joints in matters. 4 degrees is enough to get the first joint, but the other joint's not enough. I need to go higher for the other joints, and then that, because I think what I really have is I essentially have a left, right, and then an up, down, and up, down. So there's like 3 joints happening. Is that right? Left, right, up, down. Oh no, there's 4. There's left, right, and up, down, and then... Wait, is that right? Hang on. Left, right, up, down, up, down. Yeah, okay. So it probably requires more correction as you go through. I think that makes sense to me. That's a possible reason. Yeah, okay. I'm actually up with that. Like I said, it would take testing to really determine if that's it. That's a good guess of why that happens. All right. Joints can be set, or I guess chains. I'll take you out. We'll go. Good boy. He's like standing up and sitting down over and over again. Chains can be corrected over time. To return as close as possible to their rest rotations. This fixes large joint angles. This fixes large... I guess this fixes gradual... I guess this fixes joint drift as joints move over time and return as targets move and return to the rest location. Yep. And I can say requires deterministic to be disabled. Okay, send it. Yeah, dog's barking. He's trying new strategies. All right, production on. Okay. While that goes, I'm gonna grab food. I'll be back. I'm back. I've got food. Okay. All right. Next step is making legs properly ground and gravity. And at that point, it should be able to, like, totally... should be walking and be able to climb walls. Right? That's my test. As soon as I get gravity going, wall climbing should be it. And then there's just, like, an optimization there, which I don't really have to do. Once it's moving around, then it'll be time to... do physical bone stimulation, probably. Maybe not. I don't know. Maybe. Maybe some kind of physical bone thing. All right. Well, I'm going to eat. Maybe while I eat, I can actually find maybe some sources. Is it like I guess it's called active ragdoll is the term. There's that one. I don't like that one though. Yeah, and then I'm running into the problem with YouTube being garbage and actually giving me no views. 4 years, no views. Maybe just search active ragdoll. This might not be the right term. Is this just demonstration? You know what? Maybe this is good. All right, I'll play through these. I'm going to leave audio turned off, though. There's literally no audio to this. Anyway. All right. Yeah, I think this is just demonstration. Whatever. That's probably a good idea. Get like just a floating box and put a controller on it. Yep. A ball launcher. I'm looking for something else. Let me try this. I'm gonna look something up here. All right. I'm going back to this video. This is like the only one. Everything else definitely seems like it's more... I mean... I'm just going to check this one again. I don't like how it's done. In fact, I'm very much against this method, but maybe there's something... I've watched this so many times, and maybe I don't get anything out of this.
Are a great way to get characters to interact naturally with the game environment without having to add a bunch of extra animations. In this video, I'm going to cover how I was able to get an active ragdoll implemented in Godot 4.0 that could also play traditional animations imported from Blender. First, we need a rigged model with animations. Here I'm reusing the rig I set up for the Leviathan Axe video. It's essentially a Mixamo Y-bot with some animations that I merged together in Blender. We're going to need two of these. One will be the active ragdoll, and the second will play the animations that we want to copy. Give them names to help differentiate them. Here I'm just making them both local to the scene, just so I can edit them in the main scene to make the video a little easier to record. Set an animation to play on the animated rig's animation player. Now let's set up our ragdoll. Click the physics rig skeleton 3D node, then in the toolbar at the top, click the skeleton 3D button and click create physical skeleton. This will create our physics bones for us. Now clean up the generated bones. If you have a simple rig, this will be way easier, but if you have a complicated one like I have from Mixamo, you'll need to spend some time tweaking the bone collisions and removing bones that aren't needed, like the IK pole bones. Once you're happy with your bones, select them all and set the joint type to generic 6 degrees of field joint. This will give us the most control over our joints. Attach a script to the skeleton and add this line of code to start the ragdoll simulation when the game runs. Try running now and see how the ragdoll looks. If it behaves strangely, then you need to keep tweaking the bone collider sizes and joint parameters. You can alter the joints X, Y and Z limits per bone to allow for a more natural range of motion. Once you're happy, it's time to start working on getting the ragdoll animated. To get our ragdoll to attempt to match the animation playing from our reference rig, first we're going to have to find the difference in position and rotation of each physics bone and their animated rig counterpart, and secondly apply physics forces to move them into the correct position. I was originally planning on using the generic 6 degrees of field joints spring constraints to achieve the latter part for us, but after trying and failing to get these values to actually do anything for a while, I dived into the engine code to see what was going on and found out they just weren't implemented in 4.0 yet. Oh well, we can achieve this ourselves pretty easily using Hooke's law and the physics bone's linear and angular velocity properties. Hooke's law is very simple. We can calculate our spring force by multiplying a stiffness value by the displacement of the spring. Displacement in our case means difference between our current and target positions. This alone will make a spring that moves back and forth forever. We can apply some damping by subtracting a damping value multiplied by our current velocity from the previously calculated spring force. Put this Hooke's law function into the script we created earlier and export some stiffness and damping variables. Create a set for both linear and angular movement. While here, let's also export a variable for our target animated skeleton. To help see what's going on, I'm moving the animated rig to be a child of the physics rig and move them to overlap. I'm then setting the animated rig to be slightly transparent for a ghosting effect. Back in the script, create a variable to hold all of our physics bones. In the ready function, get all children of type physics bone 3D and put them into the physics bones variable. Then, in the physics process function, loop over our physics bones. We can get the animated bone and physics bone's current pose information by calling the getBoneGlobalPose function. Even though the function has the name global in it, the transforms that gets returned aren't actually global, it's relative to the skeleton the bone is from. Physics simulations tend to run in global space though, so we can easily make the transformation global by multiplying the skeleton's global transform with the pose data. Okay, let's handle the linear forces first. To calculate the displacement needed for Hooke's law, take the target transform position and subtract the current transform position from it. We can now just pass all our data into the Hooke's law function to calculate our force. Then we can just add it to the bone's linear velocity value. That's it. Now let's sort out the rotation. We can calculate the rotation difference by multiplying the target pose's basis with the inverse of our current pose's basis. We can then use the getEuler function to get this value in vector-free format. Then pass all the data into the Hooke's law function just like we did before and apply the resulting force, or torque in this case, to the bone's angular velocity. And that's all it takes. Just like the bones themselves, it can take a lot of tweaking to get the spring values feeling nice, and it really depends on how realistic or cartoony you want it to feel. I found that these values worked well for me. If you want to add an even further level of control, we can hide the physics rigs mesh too, and a third rig that will interpolate between the animated and physics rigs poses. Attach a script to this new interpolated between control, we can hide the physics rigs mesh worked well for me. Depends on how realistic or cartoony you want it to feel. I found that these values worked well for me. If you want to add an even further level of control, we can hide the physics rigs mesh too, and add a third rig that will interpolate between the animated and physics rigs poses. Attach a script to this new interpolated rig skeleton. This script is very similar to the physics skeleton script, except we iterate over every bone in our skeleton, and we use the setBoneGlobalPose override function. As we mentioned before, poses are relative to their skeleton, not the world. We can use the globalTransform.affine inverse function to achieve this. This should give you a good base to build on for your own implementations. There's some further ways you could improve this, like a way to stop the physics bones from getting trapped in the world geometry. I'm really interested in hearing your ideas. Please put any suggestions you have on how you'd improve this system in the comments below. I think that about does it.
One skeleton 3D, a child point. What? A child point. What do you mean a child point? Weird. Why'd this person reply but not a reply? What is what is up with these? This is the solution. What's with the... sounds like this was just done wrong. If you're applying forces to the physical bones, then it would be working. Yeah, probably what you would really do is you would just read in the rotation of every bone and apply the rotation. You wouldn't do any linear motion. You would only do angular. It's probably not that bad, to be honest. Oh. I'm not looking at 2-year-old comments. I should probably watch this. This is what I was looking for. Something like that. But maybe this is also not what I'm looking for, but something like this. This is definitely going to switch to physical animation if it bumps into something. Okay. I think typically what you do is you take the physical bones, you take the skeleton, you copy all the stuff to a physical, I guess you don't have to. You turn on the physical bone simulation, and then you apply some scale out over time. So what you do is you read in the animation and do some really forced rotations essentially. I guess you can also do translations, but local pose rotations to match what the animation is playing, and then you scale that out over time. So you could have some sort of death animation that blends seamlessly into a ragdoll just by playing the animation and then scaling out the influence of the animation. Alright, I'll be right back. I'm gonna watch some more. I'm gonna look around a little bit more. Yep, I'll be back. I'm back. All right, let me check this one out. Is there anything interesting?
Hello everyone, thank you all for joining us. My name is Bartłomiej Waszak. I'm a senior software engineer at Respawn. And in this presentation, I'm going to discuss different methods of using physics for animated characters in Star Wars Jedi Fallen Order. So, what is actually physical animation? So instead of simply playing an animation, we can use physics to move ragdoll bodies to follow the animation pose. And one of the consequences of that is that with physics, we can include collisions. So we play the same animation while at the same time we can detect collisions and prevent clipping. So in this video, we have two characters playing the same animation. So the character on the left just simply plays the animation as usual, but the second character on the right, it uses physics to play the same moves. So we can see that the character on the left just clips through the environment, while the character on the right avoids collisions by slightly changing the animation. So in general, we have three main methods of driving physics to follow the animation. So the first method is using motors. So the motor is a part of the joint constraint between ragdoll bodies, and they use a specified animation target to generate the local force between connected bodies. And that local force drives bodies to follow the animation target. The second method is using velocities. So in this case, we compute the velocity needed to move the body from one place to another during a given frame time. And in this way, we kind of force the body to move to reach to the animation target. And the third method is using constraints. So in this case, we create.
I'm thinking you would not want to use velocities because if you have an animation, I saw this with my ragdoll stuff where turning on ragdoll in the middle of an animation would sometimes send a limb just flying like at incredible speed. And part of it is because that's exactly what I would do. I would take the current position of the bone, I'd read back a frame, I compute a velocity, and then I apply that velocity. It's not realistic because it can just happen to be that between two frames, even though a motion is smooth, visually, it could be also incorrect physically. Like you just happen to have two keyframes that just move way too much in that span of time. And so if you compute a velocity from those two frames, you get like a ridiculous speed that just launches a body.
A new constraint.
Motors are probably best because you just have a constant force that's trying to rotate the body or rotate the bones into their desired location. So it probably does have a problem where if an animation happens too fast, the motor can't catch up. There's constraints though.
Between a dynamic body of the ragdoll and the animation target.
I don't know what you mean by constraints.
And all parameters for this new constraint, they define how we force the dynamic body to follow the animation target. And in our game, we started adding physical animation using motors. So this is the first method on this list. And we added it first on stormtroopers when they are force pulled by the hero. In this case, his body is kinematic, so it strictly follows the animation, but all the other bodies are driven by motors. And red pose, so red objects, they represent a pose only from animation, so without any physics added. And we can observe how, thanks to physical animation, legs are nicely colliding and interacting actually with an environment, so two-way interaction. And pure animation without any physics added, so red objects, would simply just clip through collisions. And our game uses Unreal Engine 4 and NVIDIA Physics as the physics engine. And I would like to share some essential details of our implementation. So first of all, there are a few physics parameters that are important to set up correctly. So the first one is the number of solver iterations. So default values in Unreal are 8 and 1. And for motors, nothing really works as you would expect with these settings. And
What? Huh? Yeah, this is like totally the other way around, really. Jolt is 10 velocity, 2 position. Apparently, physics is 8 position, 1 velocity. I mean, I guess position steps increases the accuracy more than velocity. But I mean, this is really good with 10 and 2 like that. Interesting.
And in our game and overall, when you create your own implementation, you need to go higher with these settings. You need to find the best one
Probably more
that
velocity.
fits your implementation.
At least two.
Your needs. And in our case, it was 64.
Holy crap. What? Eight times more position, 32 times more velocity. That's crazy. Also, is physics not just purely visual? I didn't think it had dynamic interaction. Like, you couldn't physically move a crate. You could have an animation. Maybe the animation's fine. You know, the animation won't clip through solid objects anymore, but pushing on other things? I guess I don't know how physics works. I thought it was purely visual. Like, if you want glass to shatter and fall to the floor, but you don't need to know anything about that glass from the actual game logic side. Yeah, spawn your particles, purely graphics, and you give sort of a collision mesh for all of it to interact with, and you say, all right, run, and then it will just run, and you don't care about where the glass goes. You can't interact with it anymore. It's purely out of game loop, essentially. If something is totally unrelated to game loop, physics. That's crazy. 64 and
Also
32.
going forward, we are using a flag e-acceleration, which is enabled for every joint. It makes it easier to set up all parameters related to mass especially. And the topic of friction or restitution.
I feel like you just did something
so
wrong.
These parameters,
I don't know why. That just
tend
seems
to
weird to me.
cause a lot of problems.
That just seems crazy. Like, that's an absurd amplification of work.
For physical animation, because higher values of friction.
I wish he would say what he means by nothing works for motors. Like, do the motors do literally nothing at all? If you add a little bit more, do they get like insane? Like they're spinning way too much or something? But I mean, I would say motors, the main issue with motors is that if you have an animation that's moving too fast, the bones are never going to catch up. The bones won't be able to catch up.
They make harder for physics to reach the animation target. And by default, we use just low values for friction and restitution. And
friction in a motor? Yeah, my thinking is that you just didn't have strong enough motors, perhaps.
The case actually of that force-pulled
But I wish they
stormtrooper,
would show what the problem
we actually
was.
use no friction at all to make it easy for the physics to reach the animation target. And another big topic here in terms of implementation details is continuous collision detection. So it needs to be enabled to have really high quality results, but it is better to disable CCD between bodies in the same ragdoll. The problem overall, big problem here is that with CCD enabled, constraint projection does not work very well in physics. So what we did, we actually ended up doing that we wrote our own piece of code to perform linear projection for all joints. So just for every joint, we kind of bring two bodies together if they separate too much above a given threshold. So in our game, after force-pulled stormtroopers, another case where we started to use physical animation is the death of stormtroopers. So here we just simply play a death animation. And as you can see, we can, we have really big flips and acrobatic movements from animations. And in the base case, we were just enabling ragdoll physics near the very end of the animation to have that like free fall with the gravity. And this solution, it worked really well for open space, but close to other collisions, as we can see here in this video, it does not give good results. So limbs are clipping through collisions, and kind of overall the sequence, it does not look very natural. So to improve that death sequence, we enable physical animation on the whole character, and we are using motors for all joints. But the main question was what to do about the root body, which is in this case the hip body. It can't be kinematic because it would easily penetrate walls, as the animation would just simply go through the wall. But we wanted still to make that root body to follow the animation strictly to perform these big acrobatic flips. So we need both collisions and we need that root body to follow the animation. So the solution was to keep the hip body as physically simulated body and create a new constraint for that body. And the constraint is between the hip body and the given animation target. So this new constraint kind of drags the physics body of the hip bone to follow the animation target. And for that constraint, for that new constraint, we remove all degrees of freedom. So we lock both linear and angular movement for that constraint. It gives the strongest matching with the animation to perform all these big flips. And the question was, with this new solution, what happens when we have an obstacle? So in other words, what to do if the hip body hits the wall and the animation target still pushes forward? So what to do about that physical body, which is just colliding right now with the wall? So what we do, we monitor the distance between the actual position of the root body and that desired animation target. And if the constraint drive for that hip body is unable to reach that target within some threshold, we just turn ragdoll to a free fall mode with the gravity. So this is how it looks, the same sequence using physical animation. So we can see how the root body detects that it's unable to move through the wall, and it turns the ragdoll into falling with gravity. So it worked really nice for our case. So these previous scenarios...
Why not just use velocities? Because to me that sounds like if it hits a dynamic object, it stops in place, right? Or I don't know, maybe he's not like quite.
They were focused on matching the animation pose
seeing
closely
exactly what it's doing.
and supporting collisions. So that was the case for stormtroopers in our
At least
game.
for the death animation like that, I would literally just say, all right, every frame, I'm just gonna compute a velocity and just apply it to the body. And if I ever get any large impacts, then I stop trying to play the animation to it. Or not even that, really. I would have the animation do like an in place without any root motion and just create a whole body impulse on every single bone to move it, like on the force push. So if it does hit a wall, you don't have to worry about it anymore. It's already a pure physics simulation.
But right now I would like to move to physical animation we did for the hero. And for the hero,
And just have it be like a couple frames at the start of like a rotation or torque, or not even that, honestly. Just maybe apply random torques. Or like pick a rotation angle and apply that to the spine and the head.
collisions ended up as not an important feature, and actually the fluidity of natural movement and the smoothness of natural movement was actually the top priority for us. And so we started with a ledge hang for the hero, so the special navigation for the hero. And here hands and forearms are kinematic, so we strictly follow the animation. And all the other bodies are fully physics driven just by motors. So we can nicely observe how just pure animation pose, so these red objects is more static, and physics is adding this nice looking layer of motion. Also because of that, actually animators could focus more on core poses and add and use physical animation to add that additional fluidity to the motion. So it worked really well. We had really great results with these settings. So using only motors to drive physics to the animation pose really gives nice looking results. It really adds a lot of fluidity to the motion, and we tried to extend the same approach to other hero navigations, and the results were not so great. So I have an example of sliding with weak motor settings. So whenever there's an obstacle or some fast changing motion, the hero just swings way too much. So we tried with stronger motors. In that case, character was just too stiff, and results were also not really satisfying us. And we also tried different approaches, mixing motors with velocities for all bodies, but still we didn't have substantially better results. So we tried something different. We came up with a different solution. We tried back weaker motor settings to get that springy, fluid behavior. And the new solution for us was a local space blend with animation pose. And in case of this sliding, we just blend 50% of the physics pose.
Yeah.
So here is the final result. And it started to look really better, especially the feeling of it. When you were controlling the hero with the stick, the character really nicely reacts to your movement. It isn't too stiff. At the same time, reactions are not too swingy. And here is how it looks in the final game. We have different pose for the hero, but the whole this action sequence really physical animation gives a lot of additional.
I wish they'd play with the
fluidity
red
and
thing turned
reactions
off so you
to
could see what it
other,
just actually looks like.
change in movement direction or every collision that happens. So with this new kind of approach,
But you know, that's also a good, that is a good visualization tool.
We started to use it in other cases.
All right, so my thought with motors is they wouldn't be strong enough to reach where it should go. But then they did have a 50% blend, which is just basically taking, I assume what they do they take the local pose transform of the animation and the current physics, which is trying to match the animation, and then they go halfway. Or they probably just go from animation halfway to the physics. That's probably how you do it. You would blend have like 100% physics or like 10% physics. Okay, so they use the same thing. They effectively have two skeletons. Well, really they have one skeleton. But they have two copies of it. One is purely animation driven, which will also interpolate to a physics pose. The physics one reads the animation. Okay, so they do the same thing actually. Yeah. They use that approach. They effectively have two different skeletons running. Uncharted's physical animations. Okay. They said Uncharted?
So here is climbing, where we blend just 40% of physics. So here, kind of the final result is subtle, but it gives that nice fluidity to the whole movement.
Or they'd have a better mesh,
wind
perhaps. A better mesh setup so that when you see the red, that's a difference. It seems like right now there's like a totally different mesh underneath this, or like these are probably just the colliders. So there could be differences in the shoulders and arms, but you don't see them because the colliders are smaller than the mesh.
I mean,
but then it seems like on the hip collider is larger than the mesh.
In this case,
so you always see it.
45% of physics with the animation. And here ropes, where we blend again 40% of physics. So we can see how legs nicely have some inertia after we stop the movement. And additionally, it gives really nice additional motion to the hero. And after that, we started again to have challenging cases. So this one was balance beam hang. It was really challenging to make it right. We can see here that it is 50% physics blend, but it was really hard to find stable movement.
I mean, honestly, if I look at it, if you turn off the red part, it's physical, it's correct. I would say this is a mistake by the animators. They didn't understand how the swing would eventually depart.
Case, it is because
I mean, this looks correct to me. Like his body is moving as it should be. Yeah, I mean, let me step through this frame by frame. Go back.
50%. And
so I step through frame by frame. His body's swinging correctly. It feels very natural. I'm ignoring the red part. I mean, that looks better than the animation. The animation would have his legs over there. That doesn't make any sense. No, their animation was actually just wrong. Because his arms are lined up. And like seeing which way his body is swaying, it makes sense to me. Honestly, I would say turn off the spine and use impulses to move the body. And if the legs aren't bent quite how you want them to be, then bend the legs more.
Have a challenging cases. So this one was balance beam hang. It was really challenging to make it right. We can see here that it is 50% physics blend, but it was really hard to find stable movement for this case. It is because of these like very aggressive characters moves, and the character just swings way too much, and the whole final.
Okay, 1 second. All right, I'm back. And probably also part of it too is that like the animation's also too aggressive. I feel like if they made the animation a little less aggressive and just let physics take over for like legs, you know, to keep the legs in place, or the legs at like a bend that makes sense.
Position of the hero is just way too off from the animation. So we tried here a different approach. So what we did, we added a partial velocity drive for just one body to stabilize the movement. So here's the code how we did that. So we compute first the desired linear velocity. So this is the velocity needed to fully move the body from the current position to the target position from the animation in one frame. Then we read the current linear velocity of the body, and we perform just linear interpolation between that current velocity and the desired velocity computed in the first line. So this is the way we kind of like feed current velocity, whatever is happening from physics point of view currently to that body, to the desired velocity that is just tries to move exactly as it is, as the movement looks from the animation. And the variable t is just the amount. It is just the amount of the blend. For the balance beam, we use 50% of the velocity drive for the hip body, and
that's a lot.
Here are the results of this new solution. So using this partial velocity drive just for the hip body nicely stabilizes the whole movement, actually without affecting the behavior for all other bodies. So it kind of keeps this fluid behavior for all other joints, which are just fully driven by motors, and still we don't go with too swingy motion. So we can really see how nicely the character reacts to the motion.
Did they show that from the front?
And this new solution. So using this partial velocity drive, results of this new solution. So using this partial velocity drive just for the hip body nicely stabilizes the whole movement.
I mean, I can't go out and do this, but honestly, I kind of feel like I want to go record myself doing this and see if they're even correct. Because I'm suspicious. I'm just suspicious.
Here are the results of this new solution. So using this partial velocity drive,
Whatever.
just for the hip body, nicely stabilizes the whole movement, actually without affecting the behavior for all other bodies. So we kind of keeps this.
Like, it weirdly looks like he's moving
behavior for all
backwards to
other
me.
joints, which are just fully driven.
It looks
by
like he's just
motors,
moving
and
backwards.
still,
How his legs move?
we don't go with too swingy motion. So we can really see how nicely the character reacts.
It has a weird look to it.
the motion.
It's like sometimes there's a mistake when animating a walk cycle where you have, just pretend like these are legs and this is the arm, where you have the arm follow the foot for some reason. That's not how people walk. My right arm follows my left leg. My left arm follows my right leg. That's generally how it moves. I feel like it's one of those cases where they just literally have it mirrored in some weird way and it just looks wrong to me. You almost don't even notice it on walks, but you can tell. You look at it and you're like, something just tells you it looks a little bit weird. And then if you know what it actually is, you know, the problem is that sometimes they animate the arms to swing in just the wrong way. Then you'll be like, oh, they messed up that animation. It seems like they might have messed this one up, honestly.
Motion.
I would hope that what they did was they got an actual person to do this, and then they cut frames out. But it seems like there's so much movement in the legs, it doesn't seem right. Also, it's so fast, how quick he moves. I don't think they really found a guy who could move this fast.
Really see how
I mean, maybe there is. I mean, this is like incredible work to do this, to effectively run with your hands.
how nicely the character reacts to the motion. So these previous cases, they were enhancing some special navigation state for the hero. But what about the ground?
Yeah, it's probably the speed. That's probably not. They probably could not get anyone to move that fast. Not even scaled up. Because I think even the fastest people go is like, part of it is you want to keep your legs straight. You don't want the swing. The swing kind of is it's stealing your momentum, is what the swing really does to you. So you either move slow, so you're not really swinging all that much, or I don't know.
Movement. So we tried to do something with.
Let me, you know what? I think what should happen. Let me look at it from the front again.
Here.
Yeah, you want your legs to be swinging this way at this moment. They're swinging the wrong way. Yeah, I think the legs are swinging the wrong way. Because if your legs are here when your arm is here, you're sliding off. You want to be kicking your legs in that direction. Into the direction that you're opposite of your hand. Doing this means your whole body is twisting out from under you and you're losing grip on your arm. Yeah, they actually messed up the animation. That actually isn't correct. At this moment, you would want your legs to be almost entirely under this arm at this moment.
The result.
Because like this, you're doing a lot of work to keep your body from twisting out from under you. And you're actually helping it because you are twisting your legs into your hand. Yeah, that's weird. I don't know what reference they got. I don't think definitely no one is moving this fast on a beam. And if they are, they probably have a lot of equipment on, or they're minimizing their swing, or they're swinging in the other direction.
Of this new solution.
I think that is the case. It just looks wrong.
So using this partial velocity drive,
it looks weird and cartoony.
Nicely stabilizes the whole movement, actually without affecting the behavior for all other bodies. So we kind of keeps this fluid behavior for all other joints.
I mean, I guess you could find a video of an actual monkey doing this. I gotta get to the bottom of this. What would this be? Like, all right, I'm looking up. I think the motion would be the same for monkey bars. The only difference is that your hands are oriented like this instead of like this. But the motion, your legs should move the same way. So I'm gonna find a video. Whoa, sorry. I think that just blasted really loud. Let me mute. Okay. Trying to look for like a good front. It is way slower for sure. So, go to the front here. Wait, what? Hang on. Oh, he's keeping his legs underneath his hand. Okay, this is already wrong. This is actually already wrong, though. This is good. This is good. His legs should already be under his hand at this point, though. These legs should be under his arm right now. So they definitely went way extreme on... I guess they didn't go extreme on the twist, but definitely the speed is kind of crazy. Because his legs are not underneath his arm when it matters the most, which is while he's stretching up. And only after his hand makes contact and this hand is off. Yeah, they did mess up quite a bit. His leg should already be under his hand. It should be, yeah, okay. I was right, they did mess up. The start looks fine because his legs are correctly underneath his arm, but then they don't move his legs back as fast as they're supposed to. His legs, that is why it looks like he's moving backwards. Because his legs are actually just out of sync with his arms. The into works, but then the loop animation's definitely incorrect. The natural motion is to have your center of mass underneath your arm. At every step, his center of mass is way off his arm. And like weirdly, his center of mass doesn't get underneath his arm until his arm is removed. So that the hand away from us is going to detach before his center mass is even like crossed the midpoint. Okay, it just crossed the midpoint and his hand's already off. Like at this point, his leg should be underneath his arm. Yeah. It should be swinging back really hard. Promising. I wish they would have an example of what that means. Unstable. Show me the video of the droid flying off his back at light speed. Like teleporting to infinity. Or something. Hmm. It's a good concept. A large threshold for slow movement, a small threshold for fast movement. Interesting. Oh yeah, he was inside the body. Okay, cool. An example. So it's funny they even let you do this, by the way, because you just kill. He definitely kills that droid landing on it like that. He injures himself. He puts like metal shards into his back, and he crushes the droid. It's funny. Sounds like they forgot to multiply by delta time. Hmm. No views? That just isn't correct. It's just not true. Yeah, 152. This is ridiculous. No! I just noticed I had audio turned off. Whatever. This is so loud. What the hell? I have like 2%.
And we have no audio. Oh, cool. Thank you.
What the blur? Spot the difference? Oh, the guy in the... Him in the seat is moving with the car. Okay. Oh my gosh. No, I want to modify this, please. This is some crazy work. By the way. The audio is like overlapping itself, so it sounds distorted. And that video was crazy blurry. No, audio.
Ungodly hour. So, my name is Mikhamak. I started my career in the games industry back in 1999 as a 3D modeler on Mafia.
When did I turn off the browser audio? Oh, I turned it off when I was looking for the monkey bar thing.
One animator at that
That's
time, and they thought I could
That's
have
what happened.
potential. And I was probably decent, so I became a lead gameplay animator on Mafia 2. After that, I helped.
Oh, this
Saka
one's actually
Games
so long. I don't know if I
make
can really
Silent Hill
watch this one.
Downpour, And in 2011, I joined the Naughty Dog's kennel as an animator. So, what physics animation means to us? It's anything animated while physically simulated. The most common implementation of physics animation is the ragdoll simulation. Basically, every game today has it in some form. We were already using ragdoll when characters die, but we wanted
I just thought of this. So I don't know if I'm really gonna have animation that needs to be influenced by physics, but I do technically have like an animation that wait a second. I'm going the other way around. Where am I? What am I thinking of? Let me think about this. Or I want to be able to shoot a part of the body and apply an impulse to it. which means I want to physically move the bone. At least in my case, I don't have a need for like blending in an animation anywhere. How do I do that? Huh. I guess what I'm thinking of is I treat the IK as the animation. Right, I treat the IK like an animation. But I have the physics body. I think this is what I do. I have... the physics body. I attach the skeleton to the physics body. That's what I've done. That's what I have. So it already works... It already kind of works like this, where if I push this thing, hopefully without launching into the air. Okay, well if I make it spin, then it gets totally messed up. I think it doesn't... Yeah, okay, I mean, there's problems if I have the legs move too much, but I think it's just a problem with the body motion. Yeah, I don't have like a gravity correction, so things behave really strangely. But yeah. I don't know why it's dropping into the ground, but it is. The skeleton is attached to the rigid body. So how would I make it so it attaches, like if I were to push a leg individually? If I were to do it treating the IK as if it was the animation pose and then blending that into a physical pose, I could do that. But I kind of feel like there's some issues there where if they disagree too much, then I think what I really mean to do is the physics body is there, and when I push on the physics body, the bone is physically pushed. The actual bone is also physically pushed. This means if I were to stand like right here in the middle and push on the leg, I don't know, but then IK is kind of a weird thing. Because IK... Here's the problem with it. This isn't really... It's a lot of tricking, I guess, is what I'm really looking at. I'm doing tricks. I'm not actually making a robot. Okay. I'm not literally making a real simulation of a robot with 6 legs. I'm making something that looks like that. So there are these no, where is it? Joint 3D. I could possibly set up something like that. These are, I believe, hinge joints is effectively what I'm using. They can rotate on one axis. This is a possible tool. I'm just thinking of what happens if I throw something at this object, right? Because what's going to happen is that I would want it to be... Perhaps what I can say is if the end bone of the leg gets too far away from the IK target, then maybe I just turn on pure physics sim. And perhaps have the leg attempt, like with a small motor or a weak motor, try to reach some default pose. Weird. But now I'm getting back into the world of literally simulating a whole robot crawler, which I'm not doing. I want it only needs to look like it. I guess just doing an interpolation to some physics simulation. And then perhaps when bodies move too much, maybe I turn on huh. Oh, maybe this is where I would actually want to have an animation. Like a get up animation. Like if it's on its back or if it's on its front. It'll do like a stand-up animation. And it just waits for like relative velocities to like calm down, right? Like, so it could still be on a moving platform that's going really fast, but like as long as it's not being disturbed too much in like a stationary pose, then it can play an animation to get up. I'm just thinking of what happens if, like, I do something where... I mean, what do I do for, like, an impact? I mean, I guess maybe I just don't allow a large impact. All right, 1 second. Oh. You know what I maybe should look at is what physical bone simulation actually does. Might be a good place to look. What is it called? I think it's a modifier. Physical Bone Simulator 3D with an influence. Did I scroll past it? No, it's just not here. Spring Bone Simulator? Physical Bone Simulator 3D. Alright, so it's just not here or something. Scene 3D Physics. Oh, there it is. Process not modification. If not bones, physical bone. Physical bone is simulating physics as false. Else if simulating, set bone to bones. Interesting. So it's in physical bone. Oh, wow. Is simulating physics. Set simulate physics. Hey, Pawn, any luck today? I got it working. I've added it. Rest correction angle. I will turn off the middle left to demonstrate. So I can do this motion to mess with it, so you can see how it's just not at the same angle as this one, but these are both in rest positions. I'll double check this is actually rest. Yeah. So it's active right now, it's running, but it just has no correction. If I turn this on to 1, it fixes over time. So I had to just get serious and write it in myself and read a bunch. What was I just looking? Here. Yeah, I'm looking to see how physical bone works. I think just what it does is it's just straight up a rigid body with constraints, and then it does a physics step, and at the end of the physics step, the skeleton modifier reads the value and sets up the pose. That's how it looks to me. Reset physics simulation. Was it simulation state? It was simulate state? Did I read that wrong? Oh, it is state. What does it do? Start physics simulation, stop physics simulation. I'll be right back. Back. Alright, reset to rest, which I'm guessing just has some cached value. That's not a cache value. I'm confused by this. Why would... Okay, I mean, it is just a rigid body, and it does have a joint setup or whatever. Oh, man, what would I... Alright, these are just thinking. This isn't even really what I'm doing, actually. So, I should be doing this. Determine if a leg is actually grounded, use a shape intersection most likely. So I think the first thing that I want to do is actually fix rest transform snapping. Should be a should ignore vertical direction of raycast. I guess should ignore vertical direction. Yeah, I just realized I really got myself distracted thinking about that. Should slide along direction of raycast. Yeah. That's the first thing I need to do. That is a problem. Do I have... Whoops. Good. Yeah, the only thing that should have changed is... Yeah, let me get rid of the physical. Get rid of that. Yeah, rest angles. So why is it adding active equals false? Isn't that not the default? It should have been off this whole time. It is supposed to be off. And then the bones are moving by fractions of a centimeter. That's great. That's cool. From points, we go from 3.2 to 3.18. Then we go from 1.9 to 2. It's just like deciding that it wants to be more or less precise sometimes. Why does it do that? Yeah, alright, let me close. Yes, and then I think no on everything else. Yeah. Add rest corrections to parlor leg, okay. And I'm actually going to was it the right thing? I hope so. I just don't want to do that one. Okay. Is there anything else that I may want to add on here? Fixed rest transform snapping. That's kind of the only one, really. Okay. So it should be... Whoops. Somewhere around here I have a limit that I apply. If I can find it. Limit to rest area. Okay. So target global rest, I think what I do is I take the coordinate target global rest. Let me think about this. Yeah, I think what I do is I take the vector between the two. I slide out the direction of the shape cast. So now it should just have a lateral, and then well, I guess I save that change, that vertical change, and then I clamp it back, and then I let it slide back up. Okay. So distance squared to target global rest. Could I possibly just allow this check? Because I know that if it's in the sphere, then I definitely don't have to do any limitation. But if I know it's outside of the sphere, then I can check if I need to limit it. But I guess I really want it to be more like a capsule shape. Like we can travel vertically some distance away laterally, but once we're at the end, then we have like that sphere distance. Next step target is next step target minus target global rest. Limit the length, circumference distance at the rest. Next step target still a global position. It's just offset by that rest location, or that rest offset, right? I want it to be a vertical column in the direction of the ray. The ray is the ray has a global transform that changes. Its local transform doesn't really change. I guess it changes a little bit. Actually, let me look at that. Where do I move it? I guess it's transformed by the whole, by this. Okay. Target global rest. The target's relative position on the first update. Man, this is weird. Okay. Next step target minus target global rest. So I essentially move it to there's 2 global coordinates, so I move it back to 0. So next step target is this is strange. Okay, no. What the subtraction does is it essentially moves it into reference of target global rest. So 0 means it's on top of target global rest. Any vertical, or I guess I say any component in the same direction, and these are also global points. So in the global direction of the shape cast is allowed. But then I want to stay in a I still want that sphere at the bottom. I mean, I think I just allow any coordinate, because if it's a collision point, I know for a fact that it's essentially a traced cylinder already, is the possible locations of the ray collision point. So I'm already good there. I just need to limit it laterally. But only if it's too far. Why would this happen? I guess it's when, yeah, it's when it comes out of comfort distance. That's what happens. Comfort distance increases or decreases. Or the body moves and the target global rest is relative to the body. It's always moving with it. So is that ray cast. So I've got it in local space of that. So I could say, it would be shapecast target position is a relative. So I can normalize this and do vertical parts. All right, here's what I'll do. I'm going to assume that this is just set one time when we load up. So I can also save it here. Maybe what I say is, instead of doing target rest position, this is like an initial update. That's probably better, right? It's false by default. I say if not as initialized. Then I can do this. A direction for the shape. Cast direction. So this will now be cast direction times cast direction dot next step target. And just to check. Okay, I thought this one actually gave the code that it uses. I'm never quite sure about this. I'm just gonna check. normal times the dot of the normal. Right, okay. Okay. So that's the vertical part. So what I say is I do next step target, subtract the vertical part. And then I limit the length to the comfort distance, so now it's just radial or lateral. And then I add back the vertical part and the target global rest. Is this correct? So I need to do this before I run that, because then this transforms it to be local to or relative to the target global rest. And then I get the vertical piece and I subtract that and then I limit its length. Is this really all it should be? I think this is all it should be. Just that change. I need to bring it over here though. Can you okay. Alright, well it looks like it's doing it correctly. Not really, actually. That's not where it should be. Why don't you fix that leg? Oh, not on me though. Yeah, it's not fixing all of its legs. Why is that one not? Really? The cast direction needs to be rotated. That's right. It's a direction, but I need to then rotate this. That's all I do. Yo, just use the basis. That must have been the mistake. Hey, why are you still not moving all your legs, though? Yeah, it fixes the one, but then not the other set. It's so weird. All right, well, these ones seem like they're working now. The one, at least the ones that it decides to fix, look good. Oh. Interesting. Yeah, these legs it just refuses to fix for some reason. I don't know why. Like, apparently some legs here are stuck in motion and they can't fix. That looks good. This one, that looks good. Okay. Yeah, alright. I need to figure out what that other issue is. Why is it doing that? I mean, I guess I can just move it over here and then see what it thinks is happening and why it thinks it's not allowed to move those legs. I must have put a bug in at some point. Because it's also walking weird now. Alright, so if I hit pause and drag this one off, so I can see what's going on here. And then I guess I'm looking at can step. Where is it trying to put this leg? There's a target here and there's a target back there. Is this the front leg target? I guess this is the front leg target is over there right now. Okay. So but they're all colliding correctly. So yeah, I mean, I guess I'll just do this, hit a breakpoint there, unpause, and then I hit escape. So if I'm looking at this right, this should just be index 0, the first leg. What are you doing right now? It is not moving. Okay, so we're not moving. We say we're grounded. Time since move, this 0.16, that doesn't seem right. Time since grounded has been 7 seconds on the ground. Time since, I mean, maybe that's correct. I don't know. Time since grounded 7 seconds. Sure, that seems right. So distance square, we are 9 meters away, or squared. We're more like 3 meters away from where we want to be. Sure, looks about right to me. Let's show this again. This is the front left leg that I'm looking at. This is where its target is currently set to, and this is where it should be. Or essentially this collision point with the bottom of the sphere right here. Maybe it's a little bit forward. Somewhere over there is where the like this red circle should be moving over here. Okay, so comfort distance is 0.1, so it should read that it's not comfortable. And then indeed it's reading that it's not comfortable. So if we are comfortable, we're waiting for a step delay. I don't have that. I check that adjacent legs must be grounded. Okay. So do we break out at any point here? Okay, so apparently one of these legs has broken out. So these are the two adjacent legs. This is like behind it. The like behind it. time since grounded is 0.017, so every frame it's moving, it seems. It seems like it's trying to move every frame. So that might be a mistake there. Time since grounded. Okay, so what about this leg? This is the leg across from it, which is also on the ground. It is also grounded on this frame. Okay. So those are both mistakes. What is our step delay? Okay, so apparently these legs are moving and then instantly grounding is what's happening because it's resetting that ground timer. So I guess I'll see why that's happening. Oh, it's reading its target position from its target global rest. Okay, so this is a problem. Okay. So because these are two different things now. I want to be within a column of this. So maybe I could just make this a helper function. I give it a coordinate and I ask it if we're close to our global rest position. Because we do the same thing here. Alright, I'm going to go and make a helper function. Returns the returns the lateral distance squared to the rest position. Okay. A transform basis. Yeah, I mean, I guess I guess I would just transform it ahead of time. And I guess I actually probably just want to do this every frame, really. Because I'm checking it, so I may as well. Okay. Coordinate minus equals target global rest. I do this first, and then I can subtract this. And return coordinate dot distance squared to target global rest. No, I actually just do that. And then return that. So I slide out the global class direction, and then I get the target global rest. Yeah, that's right. Actually, it would just be this. It's just this calculation. So cut that part. And write that as the distance. All right. Also, this is weird. Oh, I guess it is the case where the comfort. Actually, no. Can step should. No, I think the delay does only apply if it's comfortable. You know what? Honestly, maybe I just take that out and just say, whether we're comfortable or not, we have to yield for some amount of time. Because I think it's been a recurring issue now where this was wrong, but also this is probably a bug where it's preventing a leg from, it essentially like locks a leg, so it's always stepping every frame. That's meant to prevent it from always trying to step every frame. It has to yield. Alright, what did I do wrong now? Did I copy something wrong here? Time since moved. Oh, what? Huh? Oh, that only counts up while it's moving? Wait, this is weird. Time since moved should be counting up always, actually. This should always be counting up. Alright, move that. Just move that out. This should always be counting up. And then time since moved resets when we start to move. But it's always counting up. Okay. I think I may still have issues where, yeah, legs are tapping a bunch. Yeah, it's really weird. Yeah, what's up with that? That's really strange. The tapping. When we start moving, reset time since grounded. They have to wait for the other legs to be grounded. Maybe this should be it. Maybe it should be time since grounded instead. We can't step until we ground again. And grounding, I'm just going to basically make it so that I put a shape on the end of the leg. And if that shape is intersecting the ground, then I consider us to be grounded. To remain in place. Actually, I think time since moved is supposed to only count up when we're not moving. That's probably what this is meant to be. If we're not moving, increment our time since moved. When we start to move, zero it out. So we stay at 0 while we're moving. And then yeah, so while we're not moving, we're counting it up. So once we start moving, we have to wait until we stop, and then we'll start counting up. Okay. Alright, I'm not seeing the weird double tap now. Oh, okay. We're just doing a bunch of tapping. Okay. So that's still happening. I want to look at what I've changed. Everything's a week ago? What? Has it really been that long? That's wild to me. I broke it a week ago? Damn. Right, I guess let me see if like the legs are set up wrong or something. Crosshair weight. Time since grounded. I don't get how I'm seeing taps, is the weird thing. Because it taps on the ground and the other leg just has to... It lands on the ground and then it has to wait for that timer to count up. But while it's waiting, the grounded thing is counting up. Honestly, it should be adjacent legs must not be moving. We don't want to move this leg while adjacent legs are moving. Crosshair weight. For me to move, the legs have to be on the ground for 0.05 seconds. But only after I have waited on the ground for 0.15 seconds. So it's like a 3 times window. It's like a 3x window there. So I'm seeing a leg land and almost instantly come back off the ground. Why is that happening? Maybe what I could do is I could possibly like force a step to happen immediately. It's a possibility. If further than twice the rest distance. I feel like this is also not happening. Time since moved. For leg and diagonal. These are legs I want to move with it. Maybe I could say if we're further than half the rest, double the rest distance, and none of our diagonal legs have started to move, maybe we can start that move. So if they're all grounded, then I can. Like, what is this like doing right now? This like just keeps stuttering a bunch. It keeps trying to move forward. Why is that? Time since moved is only counted up when we are not moving. Oh, that's probably what the problem is. Maybe I'll say time since move started. Then. Or maybe it's more like if we recently left the ground. No, if we're not moving, time since moved counts up. Yeah, I need a new timer then, right? Since move started. You start that as infinity. And I'll mark these. How long the leg has been in motion for. Becomes infinity when it stops moving. How long the leg... Time since move stopped. I'm confused now. If we're not moving... Essentially, this is... I want us to wait for us to not be moving. You know, let's say time since grounded. We need to be on the ground. Wait for this leg to remain in place. And I wait for those to be on the ground for some time. And then... Actually, I guess this is kind of weird. The time since grounded actually handles whether or not it's being grounded. Because it becomes 0 when we come off the ground. Adjacent legs must not be moving. And have remained grounded for some time. And then if time since moved is going to count up while we are moving. How long the leg has been in motion for, only valid when is moving is true. So if leg is moving and time since moved is less than step per window, recently started moving. right? If none of our diagonals have started to move, if the leg is not grounded. Okay, so if all our legs are grounded, maybe I just say ignore that, actually. I don't know. Maybe it's fine. Okay, that was weird. Alright, so that's already a problem. What was the problem here? These legs all landed, but then these legs didn't get allowed to move. Like what? Okay. Okay, so that back leg got a target. This leg got a target, that leg got a target. Okay, weird. Now all these are in motion. Now all of those are in motion. What just happened? Why did it... That leg has decided to not move for some reason. Okay, now it's being weird. Alright. What did that other leg decide to not move? It definitely could have, I think. It definitely should have moved. Why did it not? Ah. Trying to see something, if anything strange happens here. I mean, it looks great. And then at some point it becomes not great and it starts doing weird steps. Like, why did that leg of the back just not move? Yeah, this step is really... What? Huh? I'm so confused by that. That middle leg decides to move. It's definitely more than twice the rest distance, by the way. Right now. Okay, it decides to move that time. Why is... Oh, this leg can't move because this one's moving. That's right. Yeah, look at this front leg. It does 2 steps. What is going on? Like, why did this one... These 2 legs couldn't move because those 2 other legs were moving. That was probably only happening because this front leg didn't start moving. So, I don't know. What is it? What's the issue? What's my problem? Maybe I could flip it around. I can say, don't start moving this leg if any of its pair legs have not been grounded long enough. If we're not comfortable, we are allowed to move. If we are comfortable... Yeah, let's say this. If we are comfortable... Wait a second. I do need this helper function. I do have a mistake here that I can see right now. So now we're relative to that. That's what I do. This. So distance squared will be same thing here. Distance squared to rest for next step target. I think that's a mistake, first of all, that I wasn't actually removing it and making it relative, which it should have been relative the whole time. Yeah, okay. And now those legs are permanently doing that weird step stuff. Perhaps the crosspair weight just needs to be higher? I don't know. But also it's weird because these legs land, then they have to wait 0.15 seconds to step again. And then at that time, none of the other ones are too far. It could also be that they are delayed. You know, I think we need to look at our own ones, and if we're not comfortable, we don't need to move. But if we are, we need to look at our own ones. If they moved recently, we can walk with them. Otherwise, if all of the legs are grounded, if not let me say this, and I guess I don't really even need to check that. I can say if leg time since grounded is less than yeah, let me say step delay. And if all of them have been grounded, then we can start going. So now this should stop the double step from happening. I'm still seeing like quick steps happening. Alright, let's go into super slow motion. Why is that leg not moving? What? Maybe I should do this. If further than twice the rest distance, allow an early step. Maybe this should be scaled or something. Maybe I should really be checking if my next step target is further than this. Maybe that's what I should check. Let me see if next step target is further than half the step distance. Or all legs are ready to move. And then distance squared should actually be distance squared to rest. It should be the... I mean, actually, I guess so, right? Yeah. Okay. If next step... Yeah, I want to see the next step target, not the... Well... The rest is pretty much on the step target. Maybe I could say minimum step distance. Early step distance. 0.15 or something. If all paired legs are able to move, are able to step, or recently began a step, use this distance as a minimum for early steps. If all legs are ready to move, or one of them started to move, maybe I say this. Maybe I check all legs, and then if they're all grounded, and this leg can start an early step, next step target is further than early step distance. Yeah, I allow an early step if... Yeah, let me say this. If all paired legs are able to step, use this distance as a minimum for early steps. And then step per window, if a leg started to move, has started moving in this time frame, allow this leg to move a little earlier. Or I guess allow this leg to move early to stay synchronized. Okay, so now this should be like extra correct now, or doubly improved. I can set a specific step distance to begin a chain step, or to begin a paired group step. But then I say no matter what, if any of my diagonals are moving and recently started to move, I need to move no matter what. Even if I'm like standing exactly on top of where I want to be, just start moving. Allow a move. But if all the legs are grounded, they're able to ground, then, and this leg is allowed to step early, then allow it to step early, which will then cause all the other ones to read through and say, oh, my pair partner started to move. I need to start moving too. Okay. There we go. I'll just leave that as early step distance as the default. Which I guess I should have closed and reopened this file before I saved it, because now they're all saved as zeros. When I could have just closed it and reopened, and it would have been good. Okay. Yeah, the legs really want to synchronize together, even if they don't have to step too much. They really want to synchronize. That's awesome. Okay. Like that middle leg especially, because technically that middle leg is comfortable. It's the front leg that starts or the back leg, I think, really is what's starting the walk. Turn around this thing. I'm still seeing each leg, or every group move with itself. Great. Okay. Over here. Seems like there's a little something weird happening. I'm not sure what it is. I think it's probably just grounding. Some of the grounding stuff is a bit weird. Or the tilt is a little bit weird. All right, legs must be very good now. If next step target is further than early step distance, allow an early step. Well, it's more like allow an early step if a pair leg recently started moving, or all legs are ready to move. And this one has enough distance to start the pair. That's what should happen. I really want those legs to synchronize. I want them to synchronize so much that I am actually just forcing them to. If we are comfortable and any legs start moving, just move anyway. I don't care. Just move anyway. Okay. And I think it looks good. Okay. Wrist transform snapping. All right, so there's two things kind of fixed there. If a pair leg is starting to move in this time frame, allow this leg to move early to stay synchronized. If all pair legs are able to step, use this distance as a minimum for early steps. Okay. Only this leg has been in motion for. Only valid when it is moving is true. I have to sneeze. If we're not initialized, cast direction, global cast direction, distance squared to rest of next step target is greater than comfort distance squared. Then we do some math to clamp it. Distance squared to rest of target position. If we've been on the ground. If a leg is moving, we can't move. And have remained grounded. Yeah, because the is grounded and time since grounded are just redundant checks to make. Grounded, time since grounded will be set to 0 when it's not grounded. It's more specifically that I don't want to move alongside of another leg that's already moving. If further than double rest distance, allow an early step if a paired leg recently started moving. Yep. And then there's that helper. Move it to target global rest space. Slide out the cast direction. I guess I could actually make that one line. You know, this is probably a lot easier. Should be coordinate minus target global rest. Slide global cast direction. Right, there we go. That's better. It's just kind of a lot to write all out like that. And then these transforms really want to change. It really needs this 4 to be a 5 and this 4 to appear. And this value that's essentially 0 to be closer or further from 0. It must be a little bit higher. Yeah, this stuff is just really stupid sometimes. I didn't even like modify that. Or did I? No. I didn't even modify that. What is this? Fixed rest? Yep. One last look. Good, okay. Fix vertical leg targets and leg. Improve leg. Synchronization. Can I get the whole word? I can't. And leg sync. Added helper method to compare lateral distances to for like targets. And I guess if I don't have, yeah, improve leg synchronization. with early step parameter. Force diagonal pairs to step together. When any individual leg reaches the early step distance. Force and diagonal pairs to step together when any one leg meets the early step distance. Okay. All right. Now, leg grounding. Yeah, reload. So at this point, what I have, and I have this shape RID. I think this was a mistake that I didn't mean to commit, but apparently I actually use it. Setup shape. Whoops. Yeah, but I never call this method. Yeah, essentially it just creates a copy of this shape, and the point is that I use this shape to do ground collision. So if the collision normal is aligned, I think even slightly, with the cast direction, or whichever way it would go in, probably the opposite of it or something, then I consider a leg to be grounded. There's also the case where technically the cloud is going to be large enough that a leg will be moving and grounded at the same time. So essentially it'll be a thing where I need to update grounded so that if moving is true, then grounded must be false. And no, I don't think that's a good idea. I think I allow them to both be true at the same time. And I just have to make sure that I'm doing this, right? I'm saying the leg can't be moving, and it must have been grounded for some time. The leg must be moving, and I've moved recently. And then also checking that it's recently grounded. If time since grounded is less than step delay. Essentially, this is what this resets to, this becomes 0 when we're not grounded. So if time since grounded is positive, I know that I am grounded. Which I wonder now if I even should be looking at is grounded. I am kind of using it. I'm kind of also setting it up so that it's just false when we're moving, which is kind of an incorrect thing. But is grounded should be true as long as our shape collides with the ground. The shape needs to match a bone though. It can't be set to target position. It needs to match the actual visual of that. Which means I kind of forgot. Skeleton needs to update in physics. This needs to update in physics. And then I guess the idea is that with physics interpolation, it should be showing like motion between frames. Yeah, updates, modifier updates in physics. Well, actually, I don't know. I guess it should be idle, but I need... No, I need it update in physics. Do not process modification, use advanced to process the modification manually. I mean, my only worry is that turning that on means that the legs are going to look worse now. Huh. Just weird, I'm not sure. Okay. Leg targets, leg. Somehow I need it to have a... I need to tell it a bone to attach to? Or maybe... How does this one work? I guess I do that, right? I have a bone name, and then I have it read. It looks up its hierarchy for a skeleton. It finds the skeleton, and it says, all right, here's the bone names that you can use. Which one do you want to detect for ground? And I would tell it, like, the end bone. The leaf. I would give it the leaf bones. Right. And then, yeah, I would just use the shape cast. Assuming the shape cast is a sphere, it would use that. Okay, I think that works. So let me make that... Yeah, so I need a bone index for where to put it. Shape RID. Oh yeah, this is supposed to be ground. Well, I give it a name, and then I load from the name. So this should be int. Okay, I think I might need. Export. Wait a second. I think. Hang on, I can't remember how to do this. Ugh. Something with property. Validate property. Every property info goes through this method except properties added with get property list. Okay, so I can do validate property and have it produce from the skeleton. So to look up the list, it'll find a skeleton and grab those names. And then in ready, it'll just do the same thing. It'll find the skeleton and get the bone from the bone name. Yeah, okay. Should be string name, validate property. It's also an enum, right? How does this do it? How does this do it? I still have it open. I should. Root bone name. Right. I think I see. Because these come from iterate IK. Not iterate IK. IK modifier. So it's probably here. It's not. Okay. Here then. Chain IK. Those are the gets. Those are the set property list. Property hint enum. Oh, hint enum suggestion enum hint. Enum hint is get concatenated bone names. Oh, cool. That's. And then it does set root bone name get bone set root bone name. Yeah, okay. All right. So if skeleton get concatenated names. Alright, well that's easy. It's an... Okay, I tell it's an enum hint. Right, yeah. Enum. Okay, I guess I can't do that. I export and then I tell it's an enum hint, so property. Validate property, get property list. Hint, property hint enum. Hint string would be getting the skeleton and get concatenated names. Okay. We find parent. The first ancestor of this node whose name matches pattern. Also, I think this happens every time I run validate. No, it only happens when I run update node list or something. Okay, well... No, validate property does just call whenever I run notify property list changed. Okay. I'll just make him a thing called find skeleton. Actually, isn't it on body? Does body know about the skeleton? Body does know about the skeleton, actually. I think it does. Nope. Why did I think it did? What are these extra new lines that I have? Did no one have skeleton before? Is skeleton actually here and I just don't see it? No, this is the only place I use skeleton there. What do I hear? No. Alright, this is probably fine. Whoa. Where are my hands right now? Get concatenated bone names. Great. And I feel like when this readies up, this will go to the legs and tells the legs about its body. And this one should probably obtain the skeleton, honestly. Because I think it probably needs that. Well, I guess it actually has the IK. So it can access the IK from there. Yeah, I can do like leg IK skeleton, or just I can also just track skeleton. And I don't need to find skeleton. I can just do body. Body.skeleton. Undo that. And then I can say whenever body changes, I run that. And then ground bone. It's in the scene tree and all its children are initialized. I guess I can just do like nah, I just don't like that. I just don't like that. I'm not going to be changing it, so I'm just going to leave it as on the first update. Here I have a variable ground bone ID. Start with -1. There we go. Okay. No, interesting. So I guess what I okay, I probably have to do this. And then I just make it empty. So at least when I click on it, I can do that. Now, why does this not run? Well, I guess because body skeleton hasn't loaded. Alright, so reload scene. When body is set, notify property list changed. Validate property. Oh, I'm calling it ground bone name. Just ground bone. Yeah, I was gonna say, because that should also refresh it when I do that. Alright, so then I say front left, leaf. And then I'll just go through each of these and set it. Front right leaf. Middle left leaf. Middle right leaf. Back left leaf. Back right leaf. Cool. Okay. Now those are saved. Just checking. Right. And then I would just do, if I have, yeah, I attach it to that, and then check rest collisions. Though, oh, wait a second. Oh, hang on a second. Maybe this is where I do want to just have the physical bone simulation and read those, because if I have that leaf bone, or I guess not the leaf bone, but the leg bone. Okay, it'll probably be a leaf bone collision. I can check that one. And I think the bones can collide with themselves though, but I'm not entirely sure about that. I think the bones can collide with themselves, so I have to worry about that. No, definitely not, because they can intersect each other. I think. I'm not sure. I'm not sure. Essentially, the problem is that the ground collision is weird. I need to find which of these from physics server I can even use. Yeah, their search is just actually so broken, it's crazy. It refuses to give you the result unless you like type the full name in. Or like the first word. It pulls up the first word, and then if you start typing in physics with a capital S, then it's like, oh, I've got no idea what that doesn't exist. Alright, so I'd have to do like shape, intersect some. No. Direct space state 3D. I mean, I guess maybe this one's fine. Maybe. Maybe this is fine. Checks the intersections of a shape. You know what? Maybe this is what I do. Maybe I do collide shape. Wait. Pairs of contact points. Each pair, the first one is in the shape passed. Second one is in the collided shape. Huh? In? The first one is in the shape, like inside. So if I provide a sphere and I have two spheres intersecting, the first point is inside on the surface of this sphere and inside. Huh? I don't know. I probably do rest info. There's two ways I can do this. I can do collide shape and then patch each of those points into intersect point to get colliders, collider ID, or collider RID. Once I get the RID, then I can access everything. I get that thing's mass. I get its, I get its mass, its rotational velocity, its linear velocity. I guess I actually can just grab this straight from collider. Well, I get the mass from collider, and then I probably have to do another physics server call to get the relative velocity, because this is just the colliding object's velocity. This is not the point of contact. Although I do need a normal. I guess that is kind of the problem, isn't it? I actually do have to have a normal. Well, I guess since I know it's a sphere, I could just do a ray. I could say the normal is the ray from the middle of the sphere to the collision point, and that's my normal by definition of a sphere. Yeah, the problem with intersect shape is I don't get any points or normals. Because I can't consider it on the ground if like the top of the leg is touching something. I can't consider that to be on ground. It has to be the bottom side. If it collides with more than one shape, the nearest one is selected. Honestly, I wonder if rest info, because I don't like the nearest one. That's technically the deepest collision, but I don't really want that. I'm thinking here of a situation where I have some small dynamic physics object on the ground that this leg lands on top of. What I would like to happen in that interaction is the leg kind of doesn't care about that point. It will just try to reach the ground underneath the shape. But then I need my collider to technically be able to detect both of those, but prioritize that ground shape. Which means I don't know, maybe I would like to look at get rest info and see if I can make it happen that it doesn't just select the nearest one, it returns the nearest n collisions. So if I say 2, it'll give me the 2 closest ones. If I say 3, it'll give me the 3 closest ones. Because it still does have to know, right? Yeah, it reads to me like if it collides with more than one shape, the nearest one is selected. It reads to me like that's the code. The code of get rest info knows all the collisions, it sorts them and grabs the nearest one, and then obtains information for those. That's what it sounds like happens here. So my expectation is if I go to the code, that's maybe what I'll see. Where am I going with this? I'm trying to do ground detection. I want to know if I can make get rest info return an array of dictionary. I would like that, an array of dictionary. Or just like a second version of it, which calls a second version of it where this one calls that second version, and that second version contains the code with 1, so that this API doesn't change. That's what I think. I think it's what I want. Because I need the case where I am colliding with some moving dynamic object, and that's my floor. But if I'm also touching a floor, then that's my real floor. I could be touching both of those at the same time. Okay. It's probably not seen. It would be servers. Physics 3D. Here. Get rest info. What? Here's get rest info. Equals rest info. I guess this is in jolt physics. Shape rest info. I mean, yeah, it's... Get shape, transform, translated local, query filter, collector closest. Collide shape queries. Where's the result? I guess it actually is collector. Collector get hit. Space get object. Oh wait, no, that is correct. Get velocity at position. Oh, that is right. Object. Object comes from try get object, hit body 2. Hit is collector get hit. Dang. Get closest point to object volume. Must not be called with the physics space as being stepped. Huh? Is that a... Body... Get closest point to object volume. Get closest point to object volume. I'm curious about that. Really? Why is that not? That's so weird. That's such a weird thing. This must be new. I think this is new at least. I guess I could get it as this. Does it have that? Let me do... Weird. Extension has get closest point to object volume. Interesting. Because what I could do then is I could say, get these collision points and then say, get the closest point on the object volume. And since it's a sphere, well, I guess since I know it's a sphere, then I can just, the normal is the ray of that collision point. Alright, I feel like I want to do some testing, actually. Because I can do intersect shape. Also, this is stupid. It doesn't give me points, actually, so I can't do intersect shape. Ah, man, it's so weird. It's like every single one of these I could use, but every single one just misses the one thing out of the group of things that I want to have. Get rest info, it only does one. Intersect point, I don't get normals. Intersect shape, I don't get points. It's weird. It's really weird. It's super weird. Oh, well, I mean, intersect point... Yeah, I mean, actually it's whatever, right? Intersect point is whatever. I have a specific point in space. There's no assumption that it's on a shape or anything. Intersect shape. I don't get the collision point, which is weird. So it basically makes it unusable. Get rest info is fine, because it kind of gives me everything. But not really. I don't know, it's odd. Because I'm just thinking about like what happens if there is some dynamic thing on the ground that's small. That... I mean, if it's on the ground, then it will be closer to the shape that I'm doing. I mean, I guess what I could do is I could run it twice. Because if I get something that I don't like, I can exclude that and run it again. I mean, I could actually do it the other way. I run collision with a static mask, and if I don't get a hit there, then I run a collision with a dynamic mask. Which actually probably has an issue, though. Wait a second. No, if it loads... No, that wouldn't work. Because look at the geometry here. I may have a case like this, where I have a moving platform that is very near to the ground. I mean, I don't know. I kind of need two things. I need... One thing is that the platform will take the leg away, right? Oh. Oh no. How does that platform take the leg away? And I need a leg that's being taken away to move the body. I might have an idea for how to do all of this. So maybe what I do is I do this. All right. I have my skeleton and I have my skeleton doing IK, and I have my physical skeleton. My physical skeleton will use motors to match the angles of the IK. And then at the same time, after I do that matching, or I guess not really at the same time, what I do is at the start of each frame, I teleport my... Well, I guess I don't teleport. What do I do? What do I do? I think what I do is I take my rigid body. It's okay. This is weird. All right. I take this, right? This is like my main rigid body collider, right? I take this. I move, or not move. Oh my gosh. What do I do? Okay, I think what I probably do, I think I make crawler bot. Oh, this is weird. Hang on. This is just weird. I'm not sure what's going on here. Okay, I'm gonna wrap it up soon, actually. This has been a lot of thinking, more than anything, and I'm running out of think. So, all right, I'm just gonna be quiet for a second. Okay. What I'm thinking of is just I've drifted back into trying to do a full simulation of effectively making my own crawler, which means I incur the problems of I incur more complexity there. What do I need to happen? I need it to be the case that if a leg is on a moving platform, I am applying some force back to the main body. And this is the main body. Right? I'm applying some force back to the main body. At the same time, that leg has to physically be dragged along with that moving surface. It needs to be like stuck to that surface, right? So I suppose what I can do is if I'm in collision with some surface, I copy its velocity. I take its velocity. I say, all right, we need to translate our target. We need to translate our target, right? We need to move our leg target, the IK target. I move the IK target, and then I also apply some force back onto the body. So if a front leg is swiped to the left, that should essentially be like making a small push on the body itself using, I guess, some leg mass, perhaps. Like I'll say a leg is maybe somewhere between 5 and 10 kilograms, and then apply a force to the body at the attachment point, which, yeah, I have the attachment point right there. So FL leg is the attachment point. Well, I guess not really, because I think I translate and move this. So it's kind of I guess I just cache it when I load in. So when I load, I copy my location as like where I'm going to apply force onto the main body. So what I do is if my collider is touching something that's moving, I copy that one's linear velocity to my leg. I guess I also take the fact its mass. So I also take its well, I guess I don't really take its mass. I guess I would do it. That would just be a friction thing, right? There's no impact happening. And this will still be operating on the case where I have a physical skeleton that can react to impacts, but that physical skeleton is still always doing its best to match the rigid body. This body is the source of truth, right? No matter what happens to the skeleton. I guess I can also read impacts, so maybe that's it. Maybe what I do there is I read in impacts, and if I have an impact that's moved this leg, I move my target point to where the leg is before I do IK. Because I'll have that. Because IK will run a physics process. I guess what happens is my crawler code runs, IK runs, and then physics server. Okay, not quite. Physics process runs, update runs inside of physics server, and well, it's also a bit different. I think this actually gets called at the end of physics. At the end of the physics simulation, because this only calls once. So it's when the body state changes, which, yeah, I think only happens at the end of the physics. I think it can happen twice, actually. I think that is the case because of steps. I think it's position. I think I get this one position or velocity states update, which I guess just because it's a rigid body, that's typically possible in one step. Maybe sometimes it takes 2 steps because, or more than that, because it's in collision with other things. Okay, so yeah. IK updates in physics. Physics server runs. I get into update, so I have the results of IK here. So I can't really move IK, which probably sucks, actually, that I don't get IK here. Maybe that doesn't suck, actually. Maybe that's fine. Because IK runs, IK tries to put the leg where I have target sitting at right now. And then I get in here, and I should, at least, I think this happens when at least one step has already run. So I come in here and I probably, okay, so I don't think I actually have any physics stuff, so I actually don't know about any collisions that have happened here. Possibly what I can do is I might be able to make it, essentially what I'm getting at is, if a physics bone moves, I essentially just check where the end of the legs would be on the physics simulation, and I apply, I guess not even that. What I really do is I take the change of that root bone. If the root bone has been moved, I take that and I apply, I guess I take its velocity and I copy that to my velocity. I don't know. Or maybe what I do is I just teleport it. And I drop the shape on the crawler body, which is fine. I don't have to have a shape. Not having a shape just means it can't collide with other things. But if I'm using the physical skeleton as the collider, no, wait. Okay, no, I've done it again. I had it for a second, and I just did it again. Okay. I'm going to call it there. I think what I need to is I just need to spend time thinking about it. Because I did have it, and as I was talking, I lost it. But there's definitely a way to do this where things just kind of, like, it's a waterfall effect. Things just move forward. And it sounded logical. It felt logical when I was thinking about it. It's not quite using the skeleton as the body, but sort of like that. I guess what I do is I take any changes in position. Yeah, I guess what I do is I calculate changes in position and then changes in rotation, and I create a linear and angular velocity. I don't know. It's weird. Yeah, it's weird. I think what I mean to say is I read in impulses. Contact impulses. So whenever something collides with my body, I apply that impulse to the central body at that point of impact. I guess rather what I do is that if I ever have, like, I don't know. All right, that's it for today. Thanks for watching. I'll be back tomorrow. Goodbye.